function, pumping and dumping, manipulate the market, flood it from the dark net, flood it from the deep web, keep it a secret, every exchange got the milk brain trading on the frequent.
Hello, everyone out there on the interwebs. Just give us a moment because we're just making sure that I'm not chipmunking and that the sound test comes through and everything. Oh, and I just realized I forgot to turn off desktop audio when I did our intro, so our intro sounded like we're underwater. Great. I hope this is like an omen that like the rest of the episode's going to go smooth. I'll put it this way. I was on time. I'll do a little short segment on why I was not on time in a moment. I just want to make sure the sound's coming through. Perfect. Sound is coming through. Great. One of these days we'll bump it up to like pure HD sound. But hi, welcome. Welcome out there, everyone on the interwebs. For those of you who do not know who I am or what this channel is, I am referred to on the internet as Sidepocket. Yes, that is my online name. I am one of the two co-founders of DCG 201, formerly known as DC 201 or DEF CON 201. We are one of the many, many, many DEF CON groups that spread across the United States and around the world. And we host a meeting of a bunch of hackers and tinkerers and developers and all sorts of crazy people third Friday of every month. In fact, this upcoming October 15th is going to be not only our next meeting, but our final our actual like meeting where we get to see some of us face to face. So that's going to be really exciting. We've been trying to do this for like 2 months now, and everything's been going nuts. But we're finally able to do it. It's going to be a giant explosion of happiness. And we're going to update our website and social media to reflect that after this stream. But if you want to know more about us and who we are and look at some of the past stuff we've done, you can go to our website below at defcon201.org. I also just put in chat the URL. We're also all over the social medias. Our two most popular channels, I would say, is on Twitter, which is at DEFCON201NJ. We are also really popular on Instagram, which is DEFCON201. Pretty much if you put DEFCON201 into Google or most social services, what the hell? Freudian slip. Most social media platforms where they're whether it's on GitHub or the hostducks.social instance of Mastodon or various Onion sites, things like that. So if you go to our website, we have a couple listings of those. But if you want even more, I put a master list of all of our website stuff. You can see us on social media and follow up on us, as well as places where you can watch like what we're streaming right now. You're probably wondering what that giant bar is above us. I'm going to detail about that in a bit, but let's just say that starting now until we're thinking around November 7th, we're going to be raising funds for charity. Yeah, I'll explain the charity in a bit, but I just want to get through everything else. That's what that bar above me is. That's what this QR code down below. Don't worry, it does not give your phone malware. We're tempted to do that, but it's not. So if you want a QR scan on your phone, it will bring up the donation list and stuff like that. But let's get into what this show is, because I was actually on time once and now I'm 30 minutes late. So yay, due to tech problems. Essentially, we've been doing stuff with our internet that human beings should not be doing with the internet, and finding out all sorts of things about the different services and stuff that we didn't know, aka what happens when you restart a router. And yeah, we had to basically go through Patch Tuesday in the span of like 10 minutes and figure all that out. The QR code is just an e-car, don't worry. Did you meant to say eclair? Because now you're making me hungry for eclairs. They have them at 7-Eleven too, but by the time we do this stream, it'll be all over and So what is this live stream if this is not one of our meetings at like the hybrid meeting upcoming on the 15th? Well, quite simply is that in addition to streaming our meetings, sometimes we have live stream specials. There actually is one coming up this Saturday that you definitely don't want to miss. And A/B test string, yes. If Neo was here right now, XIO, he would be screaming at all of us, as well as maybe even XLogic. Anyhow, but we also have our own cool shows that we do once in a while. I'm probably one of the more prolific streamers here on the channel because I have not one but 2 shows. That's what you get for being a co-founder of this group. A lot of people know me for the show Master of Unlocking, where I go around and I teach people how to pick locks and how locks work and all things like that. But this is not that show. The lockpicking show is the first and third Sunday of every month. This show, which was supposed to happen yesterday, but things went crazy, is called Crypto Barons. And this is where we look at cryptocurrency technologies and blockchain technologies as technologies. This is exactly why, and I won't say right now why, but this will probably be one of the last, if not the last time, I will wear the infamous blockchain, quite literally, on this show, which is fine because I've actually been meaning to get a bunch of blockchain and cryptocurrency shirts to wear instead, because the chain kind of does weird, like, what do you call it, reactions to my neck. It's a really nice thing, but the chain definitely, like, I don't know if this is entirely made out of coconut or something, but yeah, it does odd things after I wear it long enough. But this is where we look at these technologies as technologies. Sometimes we get a little bit into, like, if it's a cryptocurrency coin or a platform, like what their user base is like, the developers are like socially, and sometimes we get a little bit into the finance stuff. But what the show is mainly about is, hey, here's a cryptocurrency. What is it about? Do they have test nets? Can we run the test nets? Do they have a wallet? Let's run the wallet and see what happens. This is based on a coding platform. Let's look at the code of it. Can we run any of this code? Can we do cool experiments? And all of that sort of stuff. So that's what we do. We normally do it second and fourth Saturday of every month. Unfortunately, I couldn't stream yesterday, do a bunch of BS, so I'm streaming today. And I'll let you know ahead of time that our next show will be on October 23rd. Same time, same place, 8 p.m. So what are we kind of getting into today? Well, similar to last year when we started this show, It is now spooky season. It's spooky season. It's Halloween. Screw all those girls obsessed with pumpkin spice. I'm here for blood, carnage, Jack Skellingtons. Halloween and October. It's fall. It's like cool enough that it's not hot outside, but not cold enough where there's snow. It's one of my favorite times of year. And of course, any excuse for me to dress up like an asshole, even more than I normally do, is a great thing in my book. And so last year, as you probably remember, for October, we covered cryptocurrency technologies and markets that are on the deep and dark web, such as Tor and I2P. And then we also got a look at the Brave browser and kind of the thing that they advertise themselves for, the things that people like them for. They do some good things, and they sort of like the ooh, this is kind of weird, both tech and policy things about them. So that was kind of our spooky episodes. We're doing two completely different spooky episodes for this month, and we're going to this episode is, if you remember all the way back in February of this year, on episode 18 of Crypto Barretts, we had a show called dApps of the Dead with Crypto Zombies. And Crypto Zombies is this interesting gamification that basically you try to make a zombie video game out of code, and it actually teaches you how the programming language Solidity works, which is how a lot of blockchain based stuff is based around of it. It teaches you how to make smart contracts, all things like that, through the making this zombie game. And we had a lot of fun, and it really kicked my ass, and you really got to see how much of a noob programmer I am. Well, what we're going to do this episode is we're returning back to crypto zombies. And, I have this problem that I have with playing video games as a lifelong gamer, where when I start off on any sort of game or gamification thing, I go through the tutorial, I go through easy, I beat the game, and then I set it to the hardest difficulty possible. And there are some times where I wish I was on Twitch live streaming because I am crying as if I put razor blades in my ass crack and rode the NJ Transit bus systems. It's that level of pain and sadness. So here I am again, and what a better way to do this than for charity is we're going to return to Crypto Zombies, and we're going to look at all the advanced programming stuff. We're literally going to skip a bunch of lessons that I actually never covered, and we're going to go just straight in, heads first, tip to base, complete Niagara Falls in a barrel into the Solidity language. We're going to learn advanced Solidity concepts. We're going to look into Z-scope. We're going to look into making smart contracts with Truffle, and maybe we'll cover Libra, which apparently they have a partnership with, that terrible Facebook cryptocurrency platform. I don't know. Let's see. Someone else wrote in chat. Wrong show, I know, but I want to report that I got my progressive locks picked. Awesome. Tell me how it's going so far, and tell me what you think of the locks, because I'm not going to go into details right now, but both the tool set and the lockpick extreme set are good sets. Same thing if you get the 2 to 5 pins from the sparrows, but all of them are very different from each other. And you probably won't know if you never saw the tool progressive sets or tried to pick them, but they are different, and they both have pros and cons of each. That's why I have one set of each. And so just even in today's show, let me know in chat how that's going. That's from my other show. You'll see that on the 17th this month. But yeah, we're going to go right in, and you're going to watch me. Like when I did the Crypto Zombies and I was just learning Solidity through that, I was dying. This is going to be an even, basically, if N Commander watches this live, because he's at the Vintage Computer Festival East right now, good for him. There's a lot of cool people there. Unfortunately, I had to personally miss it this year. We were supposed to have a booth there and everything. We're doing a ton of stuff next year. And I always like to watch him suffer, and I try to pour kerosene on the fire to make him more suffer. Whether he watches this live or later on, this is probably going to be N Commander's favorite episode, even though it's about blockchain stuff, because he gets to now watch me suffer of doing things that he can do in his sleep that I'm just going to melt over. And I'm also doing this for a good cause. So without further ado, let's get into that good cause, and let's go into learning some programming stuff by trying to make a zombie video game. So we're going to flop over to the other screen here. Okay. So the landing page as usual, and by the way, just also want to note that I love interacting with chat. As you saw before, I was answering Binary Badger's question there. And so if you have any questions about what I'm programming, what's DCG 201, anything about cryptocurrency tech or finance stuff with cryptocurrency tech, even though I'm not a financial advisor. I'm also just an okay programmer. Or if you have any questions about my poofy hair, stuff about Halloween, etc., tell me in chat, because I will stop anything, especially with how much 4D chess I'm going to be doing tonight, to read all of your stuff. But if you're also just here to learn and you're going to lurk and learn stuff, as I always say, keep lurking and keep learning. As long as you're here, as long as you're getting something from out of this stream, I'm all here. Just don't be like, not just even a troll, just don't be like a lame troll or like a bot. Then I'm gonna yeet you into the sun. So this is the ZCG 201 website, as I posted earlier. This is done by Sarah Sullivan, does a great job about this. But before we get into what our episode is, I'm going to have to point this out for everyone that, again, it's Halloween time, scary stuff going around. You have spooky, scary skeletons. They shiver down your spine. Watch, we're going to DMCA for that. Black cats. We're dealing with zombies and cryptocurrency. And I'm not even just talking about the people that work at SpaceX. Things like that. But honestly, what's probably, as someone who's had firsthand experiences, this really goddamn scary. If you ever have kids or if you had a kid and something awful happens to them, whether it's the something awful website itself, or what I'm more talking about is illness and injuries and sicknesses and complications. Literally, even before our current pandemic, there's so much stuff that kids had to go through. When I was younger, I had to be hospitalized for a lot of things that now I have a super immune system for, and I'm so glad that doctors who are often working at way under their pay grade at ridiculous, stupid hours, as well as the nurses and other practitioners with them, have to help out with stuff. And so, as we decided, you can see above in the little QR code that we put up, that what we're going to be doing is from now until about November 7th, we're trying to raise, our goal is $600. Even if we don't make that goal, let's say we make $599, just saying, all that money is still going to go to the Children's Miracle Hospitals to help out the staff of all of these super understaffed hospitals, especially during the COVID pandemic, to help out kids in need who are suffering from various, disabilities and injuries and sickness that are not even COVID related. And this, speaks a deal to me. So even if you donate, and you can donate anything, like, would it be great if someone just plopped like $1 million right now? Yes. But if you have $5, if you have $1, you want to go nuts and drop a 20 once, you want to drop a deuce, you can all do that. We've done these live stream sort of charity things in the past. I'm not even expecting to make huge amounts this stream. We're really kind of saving that for our meeting on the 16th. But anything you put into will go there. Your name, even if you list it as completely anonymous, and yes, you can donate under anonymous, will be listed. And as the list grows, we will read the list of names. We always try to shout out and do really good things for the people that donate. And as I said, this episode, as well as all the future stuff until about November 7th, we might extend it into November because I know we want to do a different charity thing in December. But right now, it's from now on November 7th, we're going to be focusing on the Children's Miracle Hospitals. And you probably have heard of this organization. It's called Child's Play, not to be confused by, there is a awesome horror series called Child's Play, probably more famous by the Chucky doll, as it's called, the little possessed doll that runs around everywhere, red hair and stuff. He's kind of like, if you put like, I don't know, if you put like Deviant Ollam on Quaaludes and dyed his hair red, or if you probably give him a wart, his hair will just turn red or something. But under Child's Play, which is probably one of the most reputable and predominant children's game charities, we found out through them that not only is your donations going to go, especially excess money, to the Children's Miracle Network hospitals, but we have chosen to use the lion's share of that donations to donate directly to, and where the hell did this thing go? Did it just go? Here we go. To go to the children's, this is the correct URL, the Children's Specialized Hospital that is located in New Jersey, is a RWJ Barnabas Health Facility, and it's the nation's leading provider of inpatient and outpatient care for children from birth to 21 years of age, facing special health challenges from chronic illness and complex physical diseases like brain and spinal cord injuries to full scope of development, behavior, and mental outcomes. And there's 14 different New Jersey locations. While your donations will definitely go to children's hospitals across the nations, because we are a New Jersey group, A lot of the core money, I don't know how much in particular because we don't control the money. The charities deal that all. So we never touch the money. It's not going through a middleman. You're not donating through PayPal to some sketchy DCG 201 onion or something. It's going to go directly through reputable sources. That way we're all hands off and everything's fair. All that's going there. So again, if you do donate while we live stream, we can get alerts. And even if we're not live stream, you can go and donate. We would love to reach the $600 goal after the first week of November. We'll extend it longer if we think we can achieve more than that, but that's kind of our thing. And I'll put it this way. I'm not expecting any donations tonight, to be honest, even though I'm about to torture myself for charity right now, which is kind of like a prelude to how I'm going to reward myself for charity this Saturday, and I'll bring that up at the end of the episode. But even if I stream and there was only like $1 or $2 that was donated today, I'd be very happy about that. Real quick before we go in the episode, how can you donate? Well, I'm glad you asked. First of all, there is a QR code on the screen, and you can scan that with your phone, and it won't. Trust me, it won't go to any malware. I tested this myself because we try not to do. It's the same thing with the Instant rewards, where you get crypto for free by scanning that QR code on instant at get.instant.com. We try to avoid scams. In fact, part of Crypto Barons is us trying to warn people about cryptocurrency scams. So we always test this stuff, believe it or not, before we put it in production, which is things that we wish we could do with our own tech here at DCG 201. But, you know, we're hackers. We do everything back asswards. But you can scan the QR code. If you are on... Oh, crap. I forgot to turn the Tiltify thing on Twitch. Oops. At some point when I take a water break, I'll try to turn the Tiltify thing. Normally, the Tiltify thing at the top, we have a widget for that in Twitch, but I completely forgot to turn that on for this stream. But regardless, I do have where you can donate. So for those of you who are wondering what the actual charity fundraiser and landing page looks like, there's the URL of it in chat. And if you want to donate directly, whether you are on Twitch, DLive, or YouTube, there's the actual donations page itself. And if you click on the charity page, it will take you, you can click on a link that will take you to the donation page. So throughout this episode, I'm going to be constantly posting the donation link. Never mind, we have the QR code. And at some point, I will turn the Tiltify thing on Twitch so that people on Twitch can actually do this. But you can easily click that link or copy pasta that link over and go where you need to go. If you're on mobile, you can scan the QR code on the screen. So with that out of the way, how about this? What we'll do is we'll try to do one of these crypto zombie tasks, and then I will take a break because I have to rehydrate, and then I'll turn the Tiltify thing on Twitch, and then we'll do as many others as we can. I'm going to try to see within 2 hours or more how many of these we can do and how turtle slow it's going to take me to do all of these, because my primitive brain just... Again, I programmed in Ruby many years. I can easily edit Python code. My background is in Objective-C, C++, and JavaScript, the three horsemen of old age apocalypse, besides the super old age like Fortran stuff. Hey, Simprix. I hope I pronounced your username correctly. Welcome on board on YouTube. We just went through the fact that we are trying to raise money for charity. We're trying to raise money for the Children's Miracle Network Hospital, specifically for the children's medical place in all across New Jersey. Drinking Trump style here, aka squirrel style. That we put a link because I forgot to turn the Tiltify link on Twitch where to donate. So welcome to here. We are literally now going to go into crypto zombies. So we're going to do one of these. Then I'm going to go on break, rehydrate, cry, and rethink about my life. And then we'll try to do as many advanced topics as possible. So here's what we're going to do. So we're on landing page. What are we working on? Well, we're working on here. This is what we came back to. As I said, way back in February, we had episode 18th, which was called dApps of the Dead with Crypto Zombies. And I did the absolute beginner thing, and it took the entire episode because I'm an old man, and you can teach a dog new tricks. You just have to constantly bang that round peg through a square hole until the round peg becomes square, and that's literally what happened with me. But Crypto Zombies is really, really cool. Basically, again, as I said, we might cover... That's going to be the scary part, covering Libra. But it was mainly done for Solidity, and basically you get to learn Solidity and various blockchain programming concepts like smart contracting, which is what Solidity is known for, by essentially making a cool video game or dApp right on the website. about zombies. It's like a little like kind of fighting RTS game with zombies, and you learn how to do actual blockchain programming. And it's right on their website. You don't need to download anything extra or stuff like that. It completely runs in browser, and it's set up by the awesome people at Cleverflare. And as that page loads, I'm actually going to put the Crypto Zombies URL into the chat just in case you want to check that out yourself. And Cleverflare is sort of like is a coding site that basically uses gamification and other means to teach various sort of languages such as Golang, JavaScript, Kubernetes, Rust, Solidity, basically all the ass-hard programming languages that no one wants to learn, but you have to learn because that's the only way you can get a job under Jeff Bezos and his space captain militia on the moon landing base of Amazon. This is where they make all these coding tutorials, and of course, one of their famous gamification ones, which now I'm going to close this tab, is Crypto Zombies. Crypto Zombies. And let's look at some of the curriculum here. So as you can see, I tried to really fast do the first one again, but I didn't quite make it before we streamed, so that was that. So in for the first episode back in February, we did the Making the Zombie Factory, and then the zombies attack their victims. The next ones that I believe we're going to do is we're going to learn advanced Solidity concepts, which is going to really make me cry. We might do the ERC 712 and crypto collectibles. We might do that, but I'm going to start off definitely with the advanced Solidity concepts. Oh, you mean stormtroopers? Those are the original space Nazis, were the stormtroopers, but everyone seems to forget them, and now the Empire's done nothing wrong because it's funny when fiction mirrors real life, right? And we might do the app front end with web3.js, but we're definitely going to start with the advanced Solidity concept. So after that, we might do the ERC 712 and the web3.js. I really want to try later on doing the smart contracts and dApps with Truffle. I'm going to ignore Oracle because everyone ignores Oracle. And then we might look a bit at the Binance chain. I definitely want to look at what ZN Sync is. I don't know if we're going to do advanced ZK Sync, but we're definitely going to do the intro. And then maybe, especially if I get donations this episode, I might actually take a stick and poke out the Libra basics. For all of you who don't know, I don't remember which exact episodes, but we tried to cover Facebook's crappy blockchain platform twice now, back when it was called DM, and then after every world government yelled at them for being more megalomaniacal and dictatorship than all of them combined, they renamed it to I'm a Libra, and we covered that and how terrible that is too. So if especially I will, oh wow, we already got $20 donation. How did I miss that? We got a $20 donation already. It should pop up somewhere. Oh, Binary Badger donated $20. Thank you for donating. Okay, so guess what? No matter what thing we're gonna do, now I'm gonna do the Libra basics just for you, Binary Badger. Just for that, you get to just watch me just go into a fetal position and cry. Not only because it's even more programming crap that I have to deal with, but the fact that it's a programming platform from Facebook that I hated that I had to cover twice. So just because of that, I'm going to do that. And again, the more people donate, the more dumb concepts I'm going to try this night. We might do this to 3 a.m. in the morning. I have off of work tomorrow because it's a holiday, so I have nothing to do Monday. I'm just here with all of you folks. So without further ado, let's go into this. So again, and I'm going this blind because I barely remember the last stuff we covered with Solidity. And by the way, just to catch up, this is the Solidity website. I hate the top part of this page. As it says, Solidity is a statistically typed curly brackets programming language, which means it's a big pain in the ass, designed for developing smart contracts that run on Ethereum. It's extremely popular. You've seen Solidity pop up all sorts of places that we've covered. When we've covered Polkadot, when we've covered NFTs, all sorts of stuff. Solidity has always popped up because you need the smart contract to glue all this stuff together between token systems and blockchains nowadays. It's basically the future besides Mimblewimble. And as you can see an example here of kind of how the code looks and what the compiler sees here. So they like literally, I love this thing because you can actually edit and bump around here. So if we go like ERC20, you have all of this here and it takes that and then you get to see what it looks like in the crazy bytecode and what it also looks like in assembly, just to make sure that they let you know that Solidity is a real language. So That's what we're going to get into today. So we're going to go back and let's not remind ourselves of the zombie factory. Let's forget about how zombies attack their victims. Let's go to advanced solidity complex and concepts. And I'm going to start crying. Here we go. Starting this one up. So let's see here. Lesson 3: advanced solidity concepts. Grr, I can't slow you down, can I? No, I'm in Jersey City. Have you seen how fast the cars here? There is no concept of slow or down. Your Solidity skills are formidable, human. Well, thank you. Now that you've gotten some experience coding Solidity under your belt, we're going to dive into some of the more technical aspects of Ethereum development. When someone says, we're going to dive into, and you hear the phrase more technical, especially if it's more technical aspects of anything, you could say more technical aspects of hot dogs, you are going to have an ass-numbingly headache-inducing time. That more technical aspects is you're in hell. That's what that means. Just ask anyone who's worked in dev anywhere, even if they've dabbled in it like myself, and that just means you are asking for all the trouble. This lesson will be a little bit less flashy. Sorry, no plot twist, but you'll learn some real important concepts that will take you closer to building real dApps or dApps, which by the way stand for decentralized application, because things things like contract ownership, gas costs, code optimization, that does not exist anymore, and security, the other thing that doesn't exist anymore. You've been warned. No kitties and rainbows in lesson 3. Oh, wow, they are really... Oh, I'm probably going to hear Jack laughing in the other room through this. But a lot of densely packed Solidity knowledge. We strongly recommend that you complete lesson 2 for starting this one. Except I'm Sidepocket. I'm also from New Jersey. So I just believe in just taking the nearest hubcap and going straight down the snowy mountain without knowing what the fuck I'm doing. Plot holes will slow you down. Just ask episode 9, Rise of Skywalker. We're just going to go right into this, even though we haven't done episode 2. And I'll put it this way. If we hit enough of a brick wall that I really can't progress, we will literally go back and do lesson 2 again. And then I'll go in here. So, welcome to Nightmare Mode. Oh, great. Immunity of contracts. Yeah, wow, they really went to Final Jeopardy on this one. Up until now, Solidity has looked quite similar to other languages, like JavaScript, but there are a number of ways that the Ethereum dApps are actually quite different from normal applications. What night makes this different from other nights? I ask you out there, Jewish diaspora. To start with, after you deploy a contract to Ethereum is immutable, which means it can never be modified or updated ever again. As they say on the show, Doug, it's on your permanent record. The initial code you deploy to a contract is there to stay permanently on the blockchain. There's one reason security is such a huge concern in Solidity. If there's a flaw in your contract code, there is no way for you to patch it later, aka every programmer's nightmare besides Patch Tuesday, as well as being transferred to another spot on the planet for their job. You'll have to tell your users to start using a different smart contract address that has that fix. And that's actually what happens every time you've heard a wallet being compromised or something because of a blockchain problem. When you get that patch that updates your wallet, they haven't actually patched the blockchain. That's basically they isolate that blockchain and it's dead to me, can opener. What happens is that they basically cloned or have a backup copy of that blockchain, its last snapshot, and then they add the new stuff to the smart contracts, deploy that becomes immutable, and then the update actually tells all your wallets to look at that chain instead of the other one. Basically, you have to look at Morpheus and not look at the woman in the red dress anymore, and that's what they're trying to describe here. But this is also a feature of smart contracts. As I said, the code is law. It's law. If you read the code of a smart contract and verify it, you can be sure that every time you call a function, it's going to do exactly what the code says, which is a problem because of the way people code things, right, Jim? It will do. No one can later change that function and give you unexpected results, otherwise known as Texas government, as I take a drink to that. Oh, I'm dreading this. External, which is funny because Metroid Dread came out. External dependencies. In lessons 2, we had the CryptoKitties contract address into our dApp. But what would happen if CryptoKitties contract has a bug and someone destroyed all the kitties? First of all, screw you, asshole kitty person. You're not even probably a dog owner. You're probably just one of those like weird people that like collect spores or something and like not even just on their body. And this is a problem because there's only two things that make up the internet: cats porn that's terribly put together with a bunch of freaking Perl script dependencies. That's literally the entire internet. So f all, fuck you. Second of all, let's find out how you would have to patch this in a decentralized blockchain system. It is unlikely. Don't tempt hackers. But if this did happen, it would render our dApp completely useless. Our dApp would point to a hard-coded address that no longer returned any kitties. Our zombies would be unable to feed on the kitties. No comment. And we are unable to modify our contracts to fix it. For this reason, it often makes sense to have functions that allow you to update key portions of the dApp. For example, instead of hard coding the CryptoKitty contract into our dApp, the address I mean, we should probably have a set kitty contract address function that lets us change this address in the future in case something happens in the CryptoKitties contract. So now we're gonna have to do this. So let's update our codes from lesson 2. So let's read this here. This is to announce Solidity, what type of compile it's going to use, which is Pragma, and the version number. And then we imported the whole zombie.sol thing. And then we said the contract and we declared it and we listed all of the which goes off screen for some reason. All of the functions, and then bool, we put all those strings. We made a bunch of uh, uh, variable declarations. And then we add to the contract zombie feeding, which is in the zombie factory. And it basically points to a certain address here. And then we change that to a declaration, which is the kitty interface contract equals the kitty interface thing that we just wrote. And add set kitty contract address methods here with the function system and all the blah, blah, and all the if ends loop stuff in the function. So that's zombie feeding. And then this is what was imported, which is the .sol file, which has our OG code from way back of the zombie factory and the event, which tells you what a zombie is, how it's made up, which would be basically the hashes on a Genesis on a blockchain in each individual blocks, and then what a zombie is, which is technically the token itself or the NFT if you're into NFTs. And then mapping that all out and all the functions there. So that tells you what zombies are, and the zombie feeding tells you what they should do and what sort of base contract you should use. And now I will say, looking into this, I might have to zoom out in order to properly type in here, by the way, just because of the way everything's laid out. So let's see. Let's update our code from lesson 2 to be able to change the CryptoKitty address. So what they asked us to do is delete the line of code where we hard-coded the CK address, and then change the line which we created the kitty contract to just declare a variable, i.e. don't set it equal to anything. And then we're going to create a function called setKittyContractAddress. It will take one argument, the address, which is an address, and it should be an external function. Number 3, I know, is guaranteed going to kill me because I quite don't remember all of that. And inside that function, we're going to add one line of code that sets kitty contract equal to kitty interface, which points to the address, and then we can change the address anytime. It says, note, if you notice a security hole with this function, don't worry, we will fix that next chapter. And I think the problem is the declaration of all the different variables. I think that's what's the security problem. Now, I will say, because I'm such a middling coder, I'm going to do attempts, but I have no shame to select the just show me the answer part and then do that. Just because I want to get through with at least some sad form of sanity here. All right, so what it wants us to do is, so we delete the line of code where we hard-coded CK address. Okay, so I don't think that's in the sol file. I think that is entirely... Yeah, because this is all about actually how the zombies are made. And we couldn't change this because it's also read-only. This is us to just cross-reference. So let's see. We have to find CK address. So it sucks because I keep reading CK and I think it's PK. So I'm thinking of like Earthbound, and like Ness and Smash with PK Fire and all that type of shit. So it's a contract kitty interface. I have a feeling it's in this next second. Okay, so as the notes say, because this is how you can tell I do hacking. I did not read any of the notes because I'm an idiot. So what we need to do is we need to remove this section here. So I'm just going to remove all of this right here. Bring this back up. And then we're going to change this just so it's a declaration. So it just, let's see, kitty contract to, so it does, just to declare the variable. All right, so because it doesn't, oh, okay. So I think we're just removing the CK address part, so it just has the kitty interface. So again, it's not saying anything. Now this is the part that's going to drive me crazy. Add the set kitty contract address method here. So let's see, feed and note multiply. All right, so my problem is I don't know exactly where to put this. Okay, because it's like, I think, okay, so I have to actually erase, well, first of all, let me erase this section here. And this is the part where I have to do the function. God, this is going to kill me. So I'm going to do function, and we're going to call that function, again, set kitty contract address. Also, let me know if you can actually read the text on any of this, because it looks good on my giant TV, but it's my giant TV. If you have a hard time seeing this, I could try to zoom in a little bit more, just because, you know, crazy stuff here. So let's see. So it's gonna take one argument. So we're gonna do an underscore address. Sorry, with two D's, double D's. Oh shit, I'm an idiot. Wait a minute. So we actually have to first declare it as an address, and now it's gonna be an address. And let's see. I'm trying to remember where you add the external part of the function. If I remember correctly, it's either going to be before the declaration of what it is as an address, or it's going to be afterwards. Oh, wait a minute. Hang on. Let's see. Let's just make it external, and then we're going to add the brackets. This is the part I'm remembering. Yeah, you're also watching on TV. This is what I mean. So what I might do right now is I'm just going to zoom in one more time. It's going to kind of break kind of the whole viewing thing of this, but at least you'll be able to see a little bit bigger, you know, because who doesn't like it a little bit bigger? So let's see. So inside the function, we're going to add one line of code. So it's going to set the kitty contract equal to the interface. So let's see. So if I remember correctly, is I think it's kitty contract, and we're going to make it equal to, which is the address. And then we're going to add the semicolon, which is also the bane of my existence. All right, so I think we probably effed up somewhere. So I'm going to check answer. It's going to tell me all my problems. Yep, there's a crap ton of problems. I'm going to zoom out a bit so I can properly view them. All right, where did I screw up? I don't know what those earlier red lines are, so let's see. So screwed up at the kitty interface part with the equal kitty interface. Doesn't say equal to anything. See, I thought, okay, so maybe I should put a 0 here? Let's try that. I don't know what those above red lines are. I don't know if that's just a display error or what. Okay, so it doesn't like 0 either. Okay, so there should be no space here, I think. And I misspelled external because I am stupid. There we go. Let's try this again. See if anything changed. Okay, so still having problems with the function set kitty. If you don't mind, I'm just going to zoom all the way out just to make sure that, I'm sorry if this looks really tiny, I just want to make sure that everything's displaying correctly, because I don't think it is. I think it's stuck that way, so I'm just going to zoom all the way back in. So that should be okay enough. Okay. I'm honestly stuck, so I'm going to cheat and have them show me the answer. So let's see. So I don't know what these red lines are up here. Oh, so you just don't. Oh, okay. So when they say don't declare anything, it literally means you just leave it as is. It just declares. Okay. And then function down here. So we almost had it right. Set kitty contract address, address, space address. Was it really a space? I literally got. Okay, I'm gonna try this again. All right. Wow. All right. So maybe it was a bit more of the space. Let's see. Oh, miss. I can't read today. Okay, so literally due to a forgotten space and 2 typos, I had everything else correct. So A, I might not be as bad as I thought, but B, this always trips. That's actually been my problem with Solidity, is that it's starting to remind me. I'm going to turn the air conditioner on. It's starting to remind me of Java in that, man, is this one of the most anal languages on the planet. But I completely understand why it's such an anal language because, simply put, as it says, this is a smart contract language. I hope everyone can hear me despite the air conditioner going on. Should be far enough away that it shouldn't affect anything. And that it needs to be very specific and anal because, again, once you deploy this, you can't fix it. So I understand why, but it still kills me. So we actually got through that, so maybe I'm not as bad as I thought. Let's go to the next chapter. Yep, no, I'm not signing in. All right, so now we're doing ownable contracts. Not pwnable contracts, although we'll probably get to that in a moment. Ownable contracts. So now we're going to highlight what the security hole apparently was. So, gotcha, I was thinking of that too. So that set kitty contract address, the one that we can modify, was set to external. So that means anyone can call it, which means that anyone with any decent backend programming knowledge will be able to just change the address of the contract at any time and break the application for all their users. You would think that this is something that it's like, oh, that would be like some muggle who has no concept of programming like myself would do. But in reality, you'd be shocked at how things break so easily, even with the most advanced developers. So we do want the ability to update the address in our contract, but we also don't want anyone and everyone to be able to update it. So to handle cases like this, one common practice has emerged to make the contracts ownable, meaning they have an owner, you, who has specialized privileges. So now we get into my favorite subject as a minority, privilege. So below, an ownable is taken from the Open Zeppelin Solidity library. Open Zeppelin is a library of secure and community-vetted smart contracts that you can use to in your own dApps. After this lesson, we highly recommend you check out their site to further your learning. We're actually going to take a break, and I'm actually going to load up that website now. First, I'm going to find it thanks to advanced Haxor search engine DuckDuckGo. I think we checked this out back in February when we did this episode, or when we covered. I think maybe when we did not Polygon. I think when we covered Polkadot, we looked at Open Zeppelin. So it says Open Zeppelin provides security products to build, automate, and operate decentralized applications. We also protect leading organizations by performing security audits on their system in progress. So they literally bake their cake and eat everyone else's. It's pretty neat. So they divide into contracts. So it's like the stuff we're about to do. And then Defender, which is a platform where you can automate things and audit security on stuff. So that's pretty neat. For any of the people who want to check out Open Zeppelin yourself while we go through this, I'm going to put this in chat. And I'm actually going to use this time to once again remind everyone that if you don't notice that giant bar above me and that giant QR code to the right of me, we are right now trying to raise money for the Children's Miracle Network Hospitals, which is a charity that donates money to various understaffed and underserved and underpaid, under-resourced, and under everything hospitals from around the globe and across the United States. And in particular, while excess money that we raise is going to go to just general children's hospitals and children's section and wings in hospitals, we are focusing on these specific set of hospitals that are all over New Jersey that specifically, said specific too many times, try to help out kids called the Children's Specialized Hospital. There's about 14 of them in New Jersey. The core of the money is going to go there, and then the rest of your money is going to go to children's hospitals from all over the place. And so, because I was stupidly forgot to set up the Tiltify, there's the link again if you want to donate. Doesn't have to be a ton. You can donate $1, $2, $5, whatever. As you saw with Binary Badger, every time you donate, even if it's anonymous, I get a notification for it. Your name pops up, and you know, we shout you out, we cheer you on, stuff. Even if we're not live streaming, you can donate. And we're trying to do by November 7th to get $600. We've raised way more than $600 in the past. But, you know, we want to see, you know, we want to do something big, but we don't want to do something that, you know, we haven't done this in a while. And that's what she said. But, you know, we thought 600 would be a good number. If we got really big, we would totally set it to 2,600. Let's put it that way. I mean, I could have also probably set it to $260 just as a goof. But yeah, so that's what we're kind of getting to. So if you want to donate, you can either scan the QR code that's on the lower right side of the screen. If not, I put the link in chat because I don't have the Tiltify turned on the Twitch, sadly, because I'm dumb, where you can go and donate any amount of money you want. And, you know, we read the list constantly on live streams, and maybe we'll do something. Because Binary Badger donated $20, I'm going to do the thing I didn't want to do at the end. So thanks to you. But we're neither here or there. Let's go back and let's learn more about this Open Zeppelin craziness we're going to do. So we're going to give this contract below a read-through. We're going to see a few things we haven't learned yet, but don't worry. We're going to talk about them afterwards. It's such a programmer thing where it's like, hi, you're going to bang your head against like 10 different things that we're not going to tell you, but don't worry. We're going to tell you it after the fact. Like, we're going to just tell you to walk somewhere, and you're going to find the room of lions, and then they're going to eat you, and then we're going to let you know there's a room of lions. This is very much a programming instructor's course, let me tell you. All right, so let's look at this thing. So we have the title, which is ownable, dev, the ownable contract, is owner address functions that, and actually there's no scroll thing here, so let me zoom out a bit so I can properly read this. Ownable contract. Jesus Christ, I have to zoom out a lot. The ownable, I made it into a little stupid tiny font. Yeah, we don't want the kids to suffer. F that. They already suffer enough. Like, I don't know if you saw, but like Twitch got exposed and all the social medias went down. They suffered well enough. I mean, screw the companies that run those things. They're selling all these kids their own privacy and security, but it's not fun for them. So, you know, at least when they get sick or injured, especially, you know, America, like what is health insurance, let's help them out here. So let's see. It says the ownable contract has an owner's address and provides basic authorization control functions that simplifies the implementation of user permissions. Now let's zoom back all the way in so we can actually read this with human eyeballs. Zoom out just a tiny bit. We have contract ownable, address private, underscore owner. The event that we're going to write in is the owner transferred. So address index previous owner, comma address index new owner. So that way we can pass down between different ownerships. The owner, oh God, am I going to have to keep zooming in and out for this bullcrap? Hold on. I should make scalars for this, or at least have a bottom scroll bar for that section. The ownable constructor sets the original owner of the contract to the sender account. Let's zoom all the way back in. So constructor, which is internal as opposed to external like before, owner, the message sender, emit, owner, transfer out. You can probably bork the message sender. That doesn't sound quite correct here as I check, because I have a feeling Siricel is like yelling at me about, like, you know, the plane's about to hit and stuff like that. So just give me 1 second. I'm just checking some base updates here to see if any of the DCG 201 members or staff are complaining at me right now with how shittily I'm doing this episode. Nope, I'm good. Yeah, I'm good. Alright, put this phone away. So that's the owner transferred, and then we return the address of the owner by doing the function as the owner. And then we can return that. Throws if any other account than the owner, I guess, is trying to access it. So now we've hard lock it, so that's only owner. Which does sound like a cool screen name / porn name, or like a BDMS name. Hi, I'm only owner. I am the only owner. I only own myself. Return if... You know, I'm just going to zoom out so I can read these goddamn comments, because this is poorly done here. So we have here, allows the Return true if necessary in the owner contract. So we do the message is the owner. Allows current owner to relinquish the control of the contract. This section, renouncing the ownership will leave the contract without an owner. It will not be possible to call the functions with the only owner modifier anymore. So that sets the renounce only owner permission if the owner has access to basically step down. The next part allows the current owner to transfer control of the contract to a new owner. The new owner address will transfer ownership to, so we put that function here with transfer ownership, the address new owner, public only owner. And then finally, transfers control of the contract to a new owner, the address is that, so now we add that in as a function. All right, so that's the contract thing we're writing here. I think that's going to be that ownable.sol file. So let's see, a few new things we haven't seen here before. Let me actually check. Yeah, it was all in here the entire time. They could have just said click on the ownable.sol, but then again, I was an idiot and I didn't notice. So yay. A few things we haven't seen here before. So we have constructors. So the constructor with the brackets is a constructor, which is an optional special function that has the same name as the contract. It will get executed only one time when the contract is first created. So it's kind of like the Genesis block, but for smart contracts. That makes sense. Modified only owner modifiers are kind of half functions, because functions are already bad enough, that are used to modify other functions, such as modifying our co-founder GI Jack that's walking behind me. Usually to check some requirements prior execution. In this case, only owner can be used to limit access, so only the owner of the contract can run this function. We'll talk more about that function modifiers in the next chapter, which I believe we're not doing, so I guess yeah. And what the weird underscore semicolon does. I'll put it this way. Underscores, bane of programmers' existence. Semicolons, the other bane of programmers' existence. Combining the two, I don't want to know what the hell it does. Honestly, it's probably a child killer or something. I don't know. It's just terrible. So indexed keyword. Don't worry about that when we don't need it yet, thank God. So ownable contract basically does the following. When a contract is created, its constructor is set to owner, to message sender, the person who deployed it. That's what message sender is. So when you deploy it, you're automatically set as the owner. And that's where it adds the only owner modifier, which can restrict access to functions to only the person who's declared as an owner. And then allows you to step down and transfer something to new owner with a couple of commands. Only owner, and of course, even with this, you're probably still going to need like password verification systems, as well as like two-authenticator and encryption and stuff like that. This is not by default. Only owner is such a common requirement for contracts that most Solidity dApps start with a copy pasta of this ownable contract, and their first contract. That this is the first contract that they inherited from. Just checking the time here. We're doing okay. So we want to set the kitty contract address to only owner. We're going to do the same for our contract. So we're going to put this to the test. So we've already copied everything to the owner.sol for the ownable. So now we're going to make the zombie factory, because these two are read-only, to inherit it. So we're going to modify our code to import the contents of the ownable sol. If you don't remember how to do this, take a look at the zombie feeding sol. Okay, so we're going to import. All right. So I'm lazy here. Keyword, today, because of the amount of bullshit I'm doing, I'm lazy. So I'm literally just going to copy pasta that over and change this over to the ownable one. And I love that it's going to now change everything else in it. So it knows it's not. But now we're going to modify the zombie contract to inherit from ownable. Again, you can look at the zombie here. Okay. So we're going to inherit. So let's see. Zombie factory. Let's see how that works here. The contract zombie factory. Inherit from ownable. Okay, so let's try to see how this works. Okay, so we have the ownable, and then we're going to modify the zombie factory to inherit from ownable. So the contract can be two different things. Let's see here. Try to figure out what exactly to do. I might have to cheat again because I've reached that point in this episode. Hmm. So, trying to figure this thing out here. Just quickly checking out my stream. We're doing okay. So we modified the import, so it's now ownable. And now we're going to modify the contract to inherit from ownable. This is the part I don't know how to do. Let's see. The inset reward's about to come up, by the way. So you can get free cryptocurrency as you watch the stream. Because if you're going to watch me suffer, you might as well. I'm going to adjust the camera slightly. Earn free cryptocurrency. So let's see. If you get Kitty, external view returns. Zombie. Pools ready. Zombie feeding is zombie factory? Well, that's the stuff down there. Oh god, my brain hurts. Alright. We're gonna check answer, but I have no idea how to do everything else. So contract zombie factory. Do we have to change that over to ownable? Is that the problem? We're gonna try that. Alright. Let's see if that works. Maybe it's with a 0? Okay. Maybe it needs to be capital O? Alright, now I don't know what it wants. Whoa, really? We just write that it's... I'm dumb. Zombie factory. So we actually had to keep the original zombie factory, but we just declare it as it's ownable. Because I'm really stupid. So we actually did most of the stuff. I just didn't know about the you do it from what end. It actually makes me want to go back to that and figure out why. Oh, zombie feeding is... Oh, okay. That's where that was. All right, so it was actually the zombie feeding part where we declared it as zombie factory, so that's what we should have did the same. At least we know now. Go to the next chapter. We have 3 more out of 14. You should all be happy I'm torturing yourself for this. I should be getting a lot more donations, to be honest. So, now that our base contract, the zombie factory, inherits from ownable, we can now use the only owner function modifier, the zombie feeding as well. So, as we see, zombie feeding is zombie factory, and the zombie factory is ownable. Thus, the zombie feeding is also ownable because it's also the zombie factory. It can access the function events modifiers for the ownable contract and applies to any contracts that inherit zombie feeding. So now they literally, it's like a Russian doll nesting egg thing that's happening right now. That's what's going on with the different contracts with their functions. So now we're going to get into function modifiers. Oh, my brain's on fire right now. The function modifier looks just like a function, but uses the keyword modifier instead of the keyword function. So I guess we just replace the word function with modifier. It can be called, and it can't be called directly like a function can. Instead, we can attach the modifier's name at the end of a function definition to change that function's behavior. So let's look at this thing off to the side. So we're going to look at the only ownable. Okay. So now I know I can do this tab over here. So let's see. The ownable contract has its own owner address. This provides the base authorization for control functions. This simplifies the implementation of the end user permissions. So we do the address private owner. And then the owner constructor is set to the original owner of that contract to its sender. So that's the whole constructor right there. The owner is the message sender. That way the first person who deploys it is the actual first owner. And then the return address for the owner, which does that function. And then once again the dev. So this is the whole thing here. But then it says over here that the only owner function on renounce ownership, okay? When you call the renounce ownership, all right, the code inside the only owner executes first. So this, the function here of owner and the only owner modifier here will go first. Then when it hits the weird underscore colon thing that's driving everyone crazy in the modifier that they won't tell us what it is, even though it's very important. It's very Hong Kong kung fu film Shaw Brothers of them. The statement in only owner goes back and executes the code inside the remote ownership. So basically, when you do the renounce ownership down here, it will go back to only owner, which is this modifier. And then when it hits that underscore, it then goes back to the inside that ownership, which is the emit ownership transfer. So that's how you do modifications within the same code without directly rewriting all of your code. So while there's other ways you can use modifiers, one of the most common use cases is to add a quit require check before a function executes. Let's see. So yeah, so it's owner, and it checks that to make sure it's valid. And then if it is, it hops back to the rest of the function. In this case, only owner adding this modifier to a function makes it that only the owner of the contract can call that function, so no one else can use that and thus have a giant security loophole. I'm going to read the giant note they wrote. Giving an owner special powers over the contract like this is often necessary, but it could also be used maliciously. For example, the owner could add a backdoor function and allow him to trans anyone's zombies to himself. So even when he leaves, that's still there as a modifier. So it's important to remember that just because a dApp on Ethereum does not automatically mean it's decentralized. This is something we've been reading. We always say on the show is just because something is a blockchain does not mean it automatically has the traditional values of the Bitcoin Satoshi paper. So as we've seen, Libra is a blockchain check, but it's definitely not decentralized. It's quite the opposite. It's one of the most centralized blockchain systems on the planet. It doesn't mean it has built-in security. That doesn't mean it has built-in encryption or even built-in good encryption. That is where you have to do research and look stuff up. Sure, a lot of these stuff, like when you copy stuff from Ethereum, certain smart contracts, a lot of these have these as defaults in there, but that doesn't necessarily mean that those defaults are carried over or weren't edited out. So, or that even the newer stuff that's coming in, like Mimblewimble, are not part of this. So you have to keep all that in mind. You have to actually read the full source code, which is why, by the way, most blockchain and cryptocurrency tech, if they're good and not scams, list their source code publicly aloud. Even Libra does this to make sure that's free of special controls by the owner that you need to be potentially worried about. There's a careful balance as a developer between maintaining control over a decentralized app, such as you can fix bugs and building owner's platform, and the users with their own trust, including how to save their data and make sure it's private and secure. All right, so we got all that. So now we're going to try to restrict access to SetKitty contract address so that no one but us can modify it in the future. So we're going to add the only owner modifier to the set city contract address. So I think what we're going to add here is we're going to find the SetKitty one, and then after that we're going to put public only owner, and then pop that up. We're going to go back to zombie feeding. We're going to find the SetKitty. Set city. Okay, so it's currently external. I'm not going to copy paste it, but I'm going to put only owner in between the two. We'll see if that works. Yay! Finally we did one that just worked completely flawlessly as is. Yay! My luck is improving, which says a lot because I've been going through a lot of stuff lately in the past couple of weeks. So yeah, let's go on to the next chapter. We only have 10 more to go. Yay, we get to talk about my favorite concept, which is what happens when you eat a lot of our food around here. And that's called gas. Great. Now that we know how to update key portions of the decentralized app, which preventing other users from messing with our contracts, let's look at another way that this programming language Solidity is different from all the other programming languages. Why do we light candles and spin the dreidel? Let's talk about also what you get after a good Hanukkah party, and that's gas, besides STDs. Gas! The fuel the Ethereum decentralized apps run on. In Solidity, you have to your users have to pay every time they execute a function of your dApp using a currency called gas. Users buy gas with Ether, the currency of Ethereum, so that users have to spend Ethereum in order to execute functions on your decentralized apps. You might have seen that, like for example, we did stuff 2 DEF CONs ago with the coin droids, or sometimes when we did stuff with Mirror Mask and things like that. You'll notice that we already had a little bit of Ethereum or whatever on our wallet, and that a certain very small chunk, it was always like a point something something percentage would go through every time we like changed a menu function or something, or we deployed something out from our own program. That's the actual gas, and you probably hear gas of it called the gas fee. And of course, it's called gas not only because it's bloated and unnecessary and it makes you feel uncomfortable, but also because you think of it like a car. This is the fuel that you put in to make something go. So essentially, thanks to the futurist capitalism of United States libertarians, we now have hard-coded into the internet the old idiom that we hope would die one day as hackers, which is you have to spend some money in order to make money. So, how much gas is required to execute a function depends on how much Chris Christie ate that day. No, depends on how complex the function logic is. Each individual operation has a gas cost, like we said earlier, based roughly on how much computing resources will be required to perform that operation, such as, for example, right, the storage is apparently much more expensive than adding 2 integers, although the fans of integers might want to fight you on that. The total gas cost of your function is the sum of the gas cost of all of its individual operations. Because running function costs real money, and actually I'm just going to enlarge this. I'm going to engorge myself and make myself a little bit bigger so everyone can read. That's what she also said, and he said, and also her friend, who we can't tell what gender they are, but it doesn't matter anyhow because I just like people. Besides running function costs real money for your users, code optimization. That's a myth in coding. At least today it is. It's much more important in Ethereum than in any other programming languages. If your code is sloppy, that means you work for Google. No, if your code is sloppy, your users are going to have to pay a premium to execute your functions, and this could add up to millions of dollars in unnecessary fees across all users, something C Enron, or the Texas power grid. Why is gas necessary? Well, first of all, it's what happens when you eat too much Taco Bell or Chipotle. But for reality, Ethereum is like a big, slow, but extremely secure computer, which, of course, when we covered our episodes about scams, we want to kind of contest the extremely secure part, but at least they work on things. To me, as long as you're trying to improve security, at least you're doing something. Most people just stick cord in their ears and don't want to listen, as opposed to the cord and band, which I'm rambling. So yeah, we're just going to go with their analogy here, even though it's not fully correct in our but actually type hacker, adjust our glasses and our fedora hat. When you execute a function, every single node on the network needs to run the exact same function to verify its output. Thousands of nodes verifying every function executes is what makes the Ethereum decentralized, and its data is immutable and censorship resistant. Again, you're tempting hackers, challenge accepted. Let me go rehydrate and read the comment. Binary Badger said, code optimization, just throw more money at it. Duh. So you've now just outed yourself that the position you work for at your job is CISO. You didn't think of that. You just doxed yourself by accident. So, we've never had a CIS show in the chat, but we have a ton of questions to ask you, such as what are you doing with your life? How's everything going since the pandemic, and do you cry in your sleep? I'm just kidding, kind of. Not about CISOs, but knocking on you, Binary Badger. I'm kind of knocking on you because now I have to do the Libra stuff at the end because you donated money. And the more money that you and others donate, the more I get to torture myself. It's great. I'm like a reverse Elon Musk or something with this. The creators of Ethereum wanted to make sure that someone couldn't clog up the network with gas. Network with an infinite loop, or hog all the network resources with really intensive computations. They made it so that transactions aren't free and users have to pay for computation as well as storage. Now, this is obviously kind of a problem now to a bit, because what happens if you are an Ethereum billionaire or something? Then price is not an option. just kind of like our rich people now. And the cycle continues because at the root of all of this problem, if we actually want to have, a free equal society with money and stuff like that, like the way Satoshi wants it, we need to pass laws and bonk people. We need to bonk greedy, dumb people on the head, not make programming contracts. But I digress. Let's read their note. This isn't necessarily true for other blockchains, like the ones the crypto zombie authors are building on the Loom network. It probably won't ever make sense to run a game like I'm about to trigger Jack. I'm about to trigger a co-founder. Let me reread that sentence properly. It probably won't ever make sense to run a game like World of Warcraft directly on the Ethereum mainnet. You can't hear this on the camera, but normally G.I. Jack makes a lot of noise. As soon as I read that sentence, he has not made any noise. That's how I know that he died inside completely and is now trying to tie some sort of long rope in order to end everything because of the sentence I just said. I'm just trying to conceptualize what World of Warcraft would look like on the Ethereum mainnet. Knowing how greedy Blizzard is, it probably wouldn't be too different, but just saying. Let's read the rest of their note. But it could run on a blockchain with a different consensus algorithm. We'll talk more about types of dApps you would want to run and deploy on Loom by Ethereum mainnet in future lessons. Maybe a new one I'll torture myself with. I don't know. So how do we deal with gas besides, Pepto and war with the Middle East? We're going to use struct packaging to save gas. So in the first lesson, we went through, if you remember that episode, that there's other types of units. Such as unit 8, unit 16, unit 32. You notice how they're going up with specific number values, etc. Normally, there's no benefit of these subtypes because Solidity reserves 256 bits of storage, 256, the number that will never die, regardless of its unit size. For example, using unit 8 instead of unit, which is unit 256 by default, will not save you any gas. It will just add a bit of zest to your taco. That's also what I like to do with the ladies and gentlemen. But there's an exception for this, which is inside the structs. If you have multiple units inside a struct, using a smaller size unit, which when possible will allow Solidity to pack these variables together to take up less storage. So as their example writes in here, you have a normal struct, we have unit A, unit B, unit C. So the struct, which we have mini-me, is unit 32A, unit 32B, and unit 32C. So mini will cost less than gas than normal. Let's zoom out to read a bunch of this because it doesn't scale very well. Hold on. Because of the struct packing. Let's zoom back in. The normal struct is 10, 20, 30. The mini-me will be also 10, 20, 30. Okay, so that's the restructuring of that. For this reason, inside a struct, you will want to use the smallest integer subtypes you can get away with. This is one of the few cases, by the way, in lives, fellas and gals, where the smaller it is, the better. You also want to cluster identical data types together, such as putting them next to each other in a struct. This just sounds like really bad Tetris. So that Solidity can minimize the required storage space. For example, a struct with field unit C, unit 32A, unit 32B will cost less gas than struct with fields unit 32A, unit C, and unit 32B, because the unit 32 fields are clustered together. So if you actually list them in order next to each other, like they did up here, where it was A, B were next to each other, and C was just left blank, that apparently saves more space because, goddamn, this programming language. So now we're going to put this to the test. So in the lesson, we're going to add 2 new features to our zombies, level and ready time. The later will be used to implement a cooldown timer, just like mobile games, to limit how often a zombie can feed. So we're going to go back to the zombie feeding hole. So what we're going to do is add 2 more properties to our zombie structure. A level, which will be a unit 32, and a ready time, which is just unit 32. We want to pack these data together, so let's put them at the end of the struct. 32 bits is more than enough to hold the zombie's level and timestamps. It's going to go by 32 bits and then reset. This will save us some cost by packing the data more tightly and using unit just by using a base unit, which is 256 bits. So let's see here. I'm going to use the zombie strut. This is in read only, so I don't think we're manipulating anything here. Oh, feeding. We're going to go back to zombie factory. So here's the strut in here. So we're going to add all the new data. I think that's the only spot that we're going to change. So we have a unit DNA, and now we're going to add a unit 32. Oh, not unit, unit 32. That will be called a level. And then we're going to add a ready time. Oh, sorry. We're going to add another 32 called ready time, not to be confused with burger time. And so again, what's going to happen here is that depending on their level, which we're going to kind of compress here because it only goes up to 32 levels, we're going to use 32 bits, up to 32 bits for its cooldown timer. That should do it. Let's find out if we actually succeeded. Nope, we didn't. What is it complaining about this time? Oh, okay. What's one of the banes of programmers besides the entire Rust language as well as regular expressions? Semicolons. That's what we forgot. You know, because we're dealing with gas and I forgot the colon. There we go. Let's try this again. There we go. That's in programming. It's never the things I said. Hey, Technic 112.010. Sorry, I haven't been watching the chat because I've been all bleh with this. Thank you for following us on DLive. A little bit of background. We managed to pass 100 users on DLive. Yay. But apparently, the one last thing we need to become a crypto superstar on DLive is to have one of our video accounts like Twitch reach over 1,000. So once we reach over 1,000 on Twitch, we'll be able to update both our Twitch accounts and our DLive accounts. So I always ask people to follow us on Twitch, DLive, and YouTube, and don't worry, all the other ones are going to be online by the time our meeting happens on the 15th. But now, instead of begging for DLive, which, by the way, thank you for following us on DLive. And by the way, if you followed us on DLive, stick around because it might take a while. But at the end of this stream, I'll give a preliminary time. I'm thinking at 11 p.m. Eastern Standard Time, but it might be sooner than that, might later. So I'd say stick around. Near the end of these Crypto Baron streams, we always put a bit of lemons in and give some away. So you'll be able to get some lemons from this. That's how we always reward our DLive watchers. For you at Twitch, we're going to always raid something. So that's the way we go. But I'm just letting everyone know we're now trying to bump up our Twitch account views, which are very close. I think we're only now like 8 or 5 followers away from reaching over 1,000. And once we do that, we can upgrade everything. So just letting you know about that. There's also a charity that we're running, but we're going to do the next chapter here and then kill me. So now, stop asking me to sign in. So now we have, let's see, so 10, half of 10, follow the 4, 9 chapters left of this advanced Solidity bullshit. Time updates. And we're going to hack time now. The level property is pretty self-explanatory. Later on, when we create a battle system, which we're not going to get into, I believe, zombies who win more battles will level up over time and get access to more abilities. The ready time property properly requires a bit more explanation. So this is the cooldown period, which is, again, if you've ever played... Awesome! Ireland. How is Ireland? I know there's a bunch of hackers in Ireland, especially from the 2600 community. So, hi out there. We're one of those dirty bastard Americans where, like, your country is starting to look better and better every day, which I'm pretty sure it normally is, but it really looks that way now. At least you people have health insurance. And right now we're just trying to do, we're looking at the Crypto Zombies, which is like a sort of game that you can play by basically making a zombie dApp game. You learn how to do smart contracting and things like that. And we covered this on February this year. And now we're back at it because I'm torturing myself for charity, as you see above, which after this lesson, I'm going to talk about that again. And we're learning right now advanced Solidity concepts, such as like how to implement security properly, cooldown timers, things like that. And then we're going to do a couple of other lessons and I'm going to die. Oh, cool. Oh, so you're moving to Ireland, Binary Badger. Well, maybe you and Technic 1210 can talk to each other and work some odd cryptocurrency back-end deals for that. Because to be honest, it's probably way easier to get into Ireland than the United States. Which, by the way, if you're trying to get in the United States, if you can get through the background checks and stuff, you can. because there's way less United States citizens now, because as Bill Burr said, by the time we're done building the wall, it's just basically Americans jumping over it into Mexico because they actually have health insurance. So there we go. I also love the purple text. So let's go back to ready time, which is no relation to burger time. Properties. So this is the cooldown period. It's the amount of time zombie has to wait after feeding or attacking before it's allowed to feed and attack again. If you're confused by this concept, and you're an old fart, never played a mobile game where they try to get you out of your own money with the cooldown timers, if you've ever played a Final Fantasy game or any old school RPG, there's a system that was popularized because of Final Fantasy called the ATB, or the active ABT, or active battle time system, where when your character attacks, it has to have a cooldown period before it can attack or cast magic or whatever. Again, that's what they're talking about. If you play an MMO like World of Warcraft, you do a function or a spell, and then there's that like bar that if your like GI Jack levels last like negative seconds before you use it again because he's that elite with all of his characters. That's what we're implementing here in this little dApp we're talking about. So without it, basically, it would be a huge exploit. The zombie could attack multiple times, billions of times a day, and the game would be too easy. And just like Solidity itself, we don't want to make this too easy. We need to annoy Sidepocket somehow. So in order to keep track of how many zombies have to wait till it can attack again, we could use Solidity's time units, which totally sounds like a... I'm waiting for a cryptocurrency that's based on time. Then we are really fucked. Now wishing this was some sort of bad alcoholic concoction. So Solidity provides native units, boy, that's a loaded term, for dealing with time. So there's a variable called now, fucking now, which will return the current Unix timestamp of the latest block, the number of seconds that have passed since January 1st, 1970, back when they didn't, computer accessibility, computers weren't even accessible to human beings, never mind just accessible. So the Unix timestamp currently, as our listing example, is 15155274888. Tempted of trying to call that up as a phone number and see what I can get. Here's their note. Unix time. Pairing Unix with anything. Like if you said, here's Unix medicine, I would never take it. I'll put it this way. I'm pro-vax as possible, but if they called the vaccine, the COVID vaccine, Unix vax, I would stay away. So the term Unix time is traditionally stored in a 32-bit number. This will add to the infamous... See, remember Y2K, where everyone was worried about the millennium? Fuck that. There's the year 2038 problem, where 32-bit Unix timestamps will overflow like the buffer it is and break a lot of legacy systems, which means nothing will work, so it'll be on par with the United States government. So if we wanted our dApp to be running like 20 years from now, I think at this point it's more like 2 years from now, we could use a 64-bit number instead, but our users would have to spend more gas to use our dApp in the meantime. So this is a design decision. Now, obviously, I think if they were smart, they would do a similar ownership thing. They would have a function that would be about what the time is, so that you could basically, right before it goes to New Year, in like if it's 2037, like New Year's Eve, that the current owner could go in and upgrade it from 32-bit to 64-bit, and then hopefully the values of the currency would update to that. Now, George Carlin says, we don't have time or now variables for rational solutions, otherwise known as working as an engineer at Google. So, Solidity also contains the time unit seconds, minutes, hours, days, weeks, and years. It's just like the little neuralizer buttons in Men in Black. These will convert to a unit of time, of a number of seconds in that length of time. So 1 minute is 60, 1 hour is 3,600, which I can't remember. Either our co-founder's either coming back or Cyricell's coming back. It's going to be one of those two things. We're going to find out. It's the Cyricell. He has survived. Barely. Don't worry, I'm torturing myself doing advanced Solidity concepts, so I'm right now discussing how Unix time works. 1 day is 86,400, which is 24 hours times 60 minutes times 60 seconds, and all I hear is that stupid Rent song in my head. Things like that. So, let's see how these units can be useful. Let me read what Technic just wrote. Always get a good Irish welcome and Irish forcing vax up people, but each to their own. Who's the best crypto now? You know, I'll tell you the real sad part if I could go into this. Like, I'm personally, this is not DCG 201 thing. This is just me, and this is probably where chat's gonna explode. I'm not for like forcing people to take the vaccine. My confusion is that similar back to when we had Spanish influenza and we had chickenpox. Believe it or not, that was I remember when I was younger and I had chickenpox. Now people don't get it anymore because there's a vaccine. The measles and specifically polio. That you would think there'd be enough smart people that most people would take it, and then the remainder of them will either just fade away or die or rub their buttholes on things or whatever, and everything would be fine. But, you know, Ben Shapiro exists in this wretched timeline, so there are no such thing as smart people left. But that's just me. Yeah, I get that song stuck in my head too. So, let's see. So we have the unit last updated. Let's get back into the crypto stuff now. So we set the last updated until now, so we make that public because we need to see a public timestamp. And then we'll return true if 5 minutes have passed, since update timestamp was called false if 5 minutes have passed, and that's the whole function in return. Yeah, that's fine. Just don't get naked. If you ever wonder what the cameras are like in our place, what about Elon Musk? See, this is why I love this crowd. Yeah. Yeah, I think it's kind of hilarious that we got like they weren't evil or anything, but we got like extreme anti-vaxxers on the lockpicking stream. But I'm on like the cryptocurrency stream where you think there'd be like a ton of anti-vaxxers, and just whatever. It's like smart is dumb, black is now white, up is north. It's anyhow. Let's put this to the test and let's try to do this in the zombie cooldown and watch me all cry. I'm barely halfway through this lesson. It's great. We're going to add a cooldown to our dApp and make it so zombies have to wait 1 day after attacking or feeding to attack again. Declare unit called cooldown timer. Also, if you want to click and make the air conditioner cooler, like you can turn the fan on. I'm just saying, if you want to do that as well, that's up to you. Because it is a little stuffy in here. When I was going to go on break, I was going to readjust a bunch of things. So we're going to declare a unit called cooldown timer and set it equal to 1 day. Forget the poor grammar. That's funny because Solidity has not forgotten my poor grammar in the past couple. We literally did a huge chunk of coding of blocks of code, and I actually did every single thing correctly, and it didn't pass because I forgot to put the semicolons. Because welcome to modern computing. As you said, equal to 1 day on compile. Since we add level and ready time to our zombie struct in the previous chapter, we need to update the create zombie to use the correct number of arguments, and then we're gonna update the zombies push line. That's just hilarious. Code to add 2 more arguments, 1 for the level and the unit 32, which is not equal to now, plus cooldown timer for ready time. So now the unit 32 is necessary because the now will return a unit 256 by default, so we need to specifically only do 32 bits on this. Now cooldown timer will equal the current Unix timestamp in seconds and all the stuff we just mentioned. So let's see if we can do all of that. Oh, what was going? Oh, okay, yeah. Like we're gonna look all that later because that's part of the reason why I was late for this live stream. I'm not angry or anything. It's just one of the. Oh, jeez, it's like
no way I can help you.
It's trying to like. He fixed it, but it's like fucking like it's like a conjoined twin that shared 2 livers, and like that's what we've been dealing with all day.
Yeah, it's like I was on my way driving here.
Yeah.
All my texts were internet help.
Well, for some reason, theirs was an odd delay too, because like I messaged and then like 5 hours later you got the reply back. I chalk it up to Wall, New Jersey, because I also got bad reception there too. So yeah, if you're curious, as I said earlier, a bunch of folks except for me was down at the Vintage Computer Festival. So, but we're not dealing with that right now. We're watching me die trying to do actual programming. So, all right, so we're going to define cooldown timer. So we're going to add this here. So we're going to do cooldown time, and we're going to equal that to 1 days. And semicolon. We're not going to figure that next time. So now that we've added that, we need to go into the whole create zombie thing. And we're going to have to use the correct number of arguments that we created when we created a new zombie struct. All right, so let's see here. Zombie push. So we're going to add 2 more arguments to this. So let's see. All right, I see here. I don't know exactly where I'm going to add this, but we're going to try. So let's see. All right, so trying to figure out how I'm exactly going to add this. I'm pretty sure this was the previous lesson that I forgot. So let's see. So we're going to add 2 more arguments. We're not going to add lines of code, probably. We're just going to add 2 more. All right. I'm pretty sure I did the previous stuff right, so because honestly I can't remember, we're going to cheat. So I just want to see if it highlighted anything. Yep, so it's a zombie push part. What the hell do they want me to do? Okay, because that was one of the things I was like, we didn't have to add lines, so I figured we'd probably have to put stuff in the whole string thing with the create zombie. But I had no idea what they actually wanted to implement on this, so. So DNA, oh, so we're literally adding them in. It's always the simplest things I can't get. So we're doing 1 for the level, and then not even going to look at it. Let's try to do this on the fly and see how accurate we get. 32, which is now plus cooldown time. Add another bracket because we already add that, which means there should be like 3 of these now. Huh, why is there only... We have to add another bracket artificially. Okay. Oh, not a 0. Shift. There we go. Or, really? There we go. All right. Let's see if we got this. All right. What is it complaining to us now? Looks like we have to also update down here. Oh, wait a minute. I'm dumb. All right. So, because I can't read properly, because I'm a Neanderthal, cut. We're gonna. I did it on the wrong line, people. So we're gonna go back in. We're gonna do this on the correct line, which is down here. This is gonna be the comma 1, and then the comma unit 32, which is now plus cooldown time. And that already added the 3rd bracket, so now it should probably work. Did not work. Why is it not working again? Let's start comparing here. Function underscore create zombie. String, memory, name, unit, DNA. Oh, forgot to close because it's not a double bracket anymore. Alright, so now that one's all set. So what's the problem with the bottom one now? So we have zombie push, zombie name, comma DNA, comma 1, unit 32. Oh, keep doing this. Not unit, int. That should work. Yay! See, this is why I suck at programming, because I type everything correctly if what actually needs to be there, and then the typos kill me. Let's continue. No, I don't want to sign in. So we're going to now do more things about zombie cooldowns. Let's see. Now that we have a ready type property on our zombie, so we're going to go into the zombie feeding.sol, and we're going to implement the cooldown timer. So we have this section down here called feed and multiply, which sounds kind of creepy. Let's see. We're actually going to type something called underscore trigger cooldown. I need to sip this. Yep, we've gotten to that part of the internet. So let's see here. So this should be like feed and multiply. So we're gonna feeding triggers a zombie's cooldown, and we're gonna modify it so that zombies can't feed on kitties until their cooldown period is passed. This will make it so that zombies can't just feed on a limited amount of kitties and multiply all day. Also sounds like we should spade and neuter our zombies as well. The future, when we add battle functionality, we'll make it, which we're not, so I'm going to skip that. First, we're going to define some helper functions that let us set and check a zombie's ready time. So we're going to pass structs as an argument. Let's see here. We can pass storage pointer to a struct as an argument as a private or internal function, as we did previously when we declared things as external or internal. This is useful, for example, for passing around our zombie structs between functions. So the syntax for it is, I love what they write here, functions underscore do stuff, zombie storage underscore zombie internal, and then the do stuff with the zombie and then the bracket. So that way we can pass a reference to our zombie and a function instead of passing it in a zombie ID and having to deal with all that mess, which would cost more gas. So now we're going to define a trigger cooldown function. It's going to take one argument, a zombie underscore zombie, a zombie storage pointer. The function should look internal. All right, so we're going to put all of that here. I'm going to use this upper part as a reference. So it's going to be one argument. So we're going to do, so the function itself is going to be called trigger cooldown. And it's going to have zombie storage. And that will be defined as underscore zombie. And then we go past the auto bracket here and put it as internal. And then I believe there's a semicolon after. No, there's not a semicolon. Wait a minute, it has to be an open bracket. There we go. So that's our function. And then the function body should be set to the underscore zombie ready time. To unit 32, which is, okay, all of that. So if I remember correctly, the way we're going to do this is underscore zombie ready time. We're going to do equal to, all right. So we added that. And now we're going to do the is ready down here. It's probably going to complain to me about something. So now we're going to create a function called is ready. I feel like we've been already streaming for like 5 hours instead of like roughly 2 hours. But again, I am doing frustrating stuff. Oh, and get this, someone already donated money, so because of that, I actually have to look at the Libra coding stuff at the end. Fun! This function will also take a zombie storage argument, okay? That is also underscore zombie. But this one is going to be internal. Internal view. It's going to return a bool. Okay. Probably screwed up here somewhere, but I don't care. We're going to keep going. Also a wrong bracket. Correct brackets. Actually, let me... What did it just do? Wait, no. Go away. There we go. That. Alright. Function body should now return zombie ready time greater than now, which will evaluate either true or false. This function will tell us if enough time has passed since the last time the zombie's been fed. Alright, so I think we have to do like an if and thing here. Oh, I see how this is set up. Hang on. So, I think this is how this works. I'm usually wrong, but let's see. So now we're going to do the zombie.ready time. Now. Return. figure out something here. I'm just going to make sure if everything above is correct, and then we'll see actually how to do that function here. So we're going to check the answer and see what we screwed up. All right, so there's a problem with the cooldown thing that we wrote. Trigger cooldown. Is there no space here? Let's try that again. Oh, there's no spaces there. Okay. So let's see. Unit 32. I'm supposed to actually add the math equation here. Maybe that's what it's supposed to be. Let's find out. Apparently not. Hold on. Or is it my old enemy, the semicolon? Let's find out. Not the semicolon. Let's see here. Mm-hmm. 32. All right, I'm stumped. Let's see what they actually want us to do. Okay, so we were supposed to type out that entire thing. Semicolon. Okay, so that works. Now we're going to do the is ready, which doesn't need that space. Now here was the part that I got confused. Internal view. Oh, okay. Yeah, because that's the return. I forgot that that's an outside function, and then you have to like bottle it in, and then space. This is all the stuff that I couldn't remember from the previous episode because I'm dumb. And now we do the time equals now with the semicolon. Actually, sorry, the whole thing. So as we did again, so now we've defined the return. This is that whole thing that they told us to type. So this is the underscore zombie dot ready time. I told you I'm not the most advanced programmer out there, so just bear with me now. And that should automatically do the whole if return true statement. Except apparently there's another problem that I'm not seeing somewhere. Function underscore is ready. Zombie storage underscore zombie. Internal view returns. So it's returns is the actual thing, and then return is the actual function body. Okay. Oh, this is hell. How many more of these we have to do? 9, 10, 11, 12, 13. We have like 7 more. 7 more of these, and then I can take a break. I should really be getting more donations for the amount of torture I'm doing, but I'm not a beggar. I'm just letting everyone know this. Because after we do this whole advanced thing, I'm going to take a break, cry, bang my head into a wall, rehydrate, set up the Tiltify on our Twitch, and then we're going to get back and do more stuff. Actually, depending on the time, we might go straight into the Libra stuff, but we're going to just try to do as many lessons as we can. That's because I'm trying to end this all around 11. So now we have public functions and security, 2 things that don't really mesh well together, but let's find this here. So now we're going to modify feed and multiply to take over the cooldown timer into the account. So we're looking back at the function. We made it public, right, in the previous lesson. Important security practices to examine all of your public and external functions and try to think of ways users might abuse them. I'm glad that that crypto zombies is automatically trying to teach people how to do security, because most programming stuff just teaches you the programming part and lets you try to figure out security as like some sort of like extracurricular course or something, which is why most programmers suck dick at security. I should even say that because like sucking dick for some people is a good thing. Completely guru meditation security. So let's see. So remember, unless these functions have a modifier like only owner, any user can call them and pass them any data they want. Re-examining this particular function, the user could call the function directly and try to pass any target DNA or species they want to. So this would be able to change all the zombies in the game. This doesn't seem very good. So we want them to follow what we wrote because we are the triangle dictators, damn it. So on closer inspection, this function only needs to be called by feed on kitty. So this is the easiest way to prevent this is we're going to make this internal so only feed on kitty can access that. So here's what we're going to do now. We're going to go into the zombie feeding and we're going to create feed and multiply is a public function, okay? So we're going to find that in here. Developers don't need to think about security. That's silly. I mean, it's up to the security team, but what needs to happen really is multiple departments to talk to each other. The dev people need to talk to the security people people need to talk to the dev people, the CSO needs to communicate with everybody, the project leads, the testing, everyone needs to talk together because it's like a pirate ship, and that's how you get everything done. I know this from working in video games. If you don't do that, you're either really sucky or you can brute force things like your Amazon. Let's see. Feed multiply is a public function, so we're going to make this internal. So the contract is more secure. We don't want any users to change the DNA stuff. You concur, yep. Let's make feed and multiply. Take our cooldown timer into account first. So we're going to make this function internal here. Let's see here. So we look up my zombie. I can't read what you typed there. Hold on a second. Oh, okay, those are two emojis. Cool beads, thank you. Also, I just want to remind people while I'm killing my brain over here, because we're basically, yeah, we're halfway done. Well, you know, I'm not just torturing myself because I like torturing myself. I mean, that's part of it. But a big thing about tonight's stream, and we're going to be doing this until about November 7th, depending on how well we do. We are trying to raise money for the Children's Miracle Network hospitals. These are hospitals. It's a nonprofit organization. They raise money for children's hospitals in the United States and Canada for understaffed, underfunded hospitals. And a good chunk of the money is just going to go to any of the hospitals under the Children's Miracle Network hospitals. But thanks to our folks at Child's Play, we have found this awesome group of hospitals called the Children's Specialized Hospitals, which is the nation's leading provider of independent outpatient care for children from birth to 21 years of age, featuring all sorts of health challenges from chronic illnesses, physical disabilities, and injuries, diseases such as the current pandemic and stuff. And they're located at 14 different places in New Jersey. And because we are a New Jersey group, while we do want to donate money to all the children's hospitals in need, a good chunk is going to go to them. So because we don't have the Tiltify set up, you can either scan the QR code that's on the screen on your phone if you want to donate. Trust me, it's not a man in the middle because we tested it out ourselves. Or you can use the link I just posted in chat to go there. Tailed it through Tiltify. We don't test that. We don't touch any of the money. And we're not even asking for a lot. Like if someone wants to drop $1 million in chat, I would literally die on the network right now, but on the stream. But if you have $1, $3, $5, 10, whatever, any amount in USD or can convert to USD, you can donate it. Our goal is we're trying to reach 600. Let me put it this way. Even if we don't even reach our $600 goal by November 7th, we are still, all that money that's donated is still going to go to help sick kids. So you don't have to worry about, yes, in order to help out all the poor, unfortunate children to live in New Jersey, although to be fair, if you've seen New York and Texas and Florida and everywhere else recently, that's not Canada and Mexico, there's a reason why a lot of people are moving to this state. Just saying. Like, your sense would be more true about, like, 5 years ago, but because of the recent stuff, it's actually a decent place. Just ask all of the people from Brooklyn who are running all over to Jersey City and Newark, driving up all the real estate prices. Yes, for example, like dead serious, like think of all the children's hospitals and children's hospital wings in Flint, Michigan. Think of all the children's hospital wings that either are near or serve native indigenous reservations, you know? Think of all of like, you know, places that serve like military vets and families, and we all know how terrible vets are treated in our healthcare system, never mind normal Americans. This is a whole thing. Yep, people are moving to Florida, and it's Florida, so they don't count. But yeah, I'm going to post it once more again. You can go to the link that's in the chat if you want to donate any amount of money. I'm already happy that Binary Badger has sent $20 already. It was way more than I was expecting to do this stream because this was just the first bat squeak of a test for the charity. But anything will account. Old New York's and old New Jersey. It's moving to Florida. Don't apologize. That was their choice. They might. Honestly, they're probably more at home there. So good for them. You know, as you say, every couple of days you need to take out the trash. So that's the way that works. But you can go to that link to donate as well as scan the QR code on the screen. Let's go back to My Suffering. So, which is funny enough, not the name of an album to My Chemical Romance. Let's see. So what we're gonna do here is we're gonna make this internal. So let's see what they asked of here. So we're going to make this function internal. So I believe we just changed it from public to internal, and that's how that works. Internal, because I've done, let's see, INTRNAL, because I have done way too many typos tonight. I'm going to take feed and multiply. All right, so. And we're going to do the cooldown timer. So first we're going to take my zombie, which does sound like Capcom Resident Evil payment service. Let's see, we're going to take my zombie, and we're going to look at the require statement. Oh, we're going to add a require statement. That checks is ready and pass it to my zombie. So let's see here. Messages, storage, my zombies, target DNA, DNA. The only problem with that is that it's not good bagels because they don't have the New York, New Jersey water, which is one of the many secrets for creating those.
Yeah.
So they might have like it's kind of like people who program in Go. They have the right structure, but they don't have any of the actual components to make anything work. Let's see here. Let's add the require statement. I say this as I'm getting stumped on this. So after we look up my zombie, let's add a require statement. So I think to add the require statement, yeah, we have to add it is ready above that. So let's see. So we're going to do. I'm trying to remember how I did this before. A minute. Okay. I think it has its own space too, if I remember correctly. Actually, I'm going to re-look up how they did the require, I believe, in the Zombie Factory. Although, wait, isn't that a modifier that we're adding? I think it's a modifier, so we're going to figure that out. Yeah, here it is. I'm going to just copy pasta from here if I can. Let's see. They're doing the only owner. Let's see, require. Instead of is owner, we're going to do is ready. And that should do this. If we did everything correctly, which, it's me, so we probably didn't do everything correctly, but if we did everything correctly, that's how that should work. So hold on to your butts. Now at the end of the function, we're going to do the trigger cooldown. We're going to call that. And I probably screwed something up, but let's try. Alright, what did I screw up on? Probably a ton. Only owner require is ready. Hates that semicolon down there. Modifier. Let's see. So it seems like we did the internal stuff really well. So we don't have to do that. It's the trigger cooldown part and and this part. So maybe this. Let's see what they want us to do. Because I'm having that type of night. I'm happy to be here live streaming, but let's see. Oh, we're just adding that line. It's not even a modifier. Great. I'm the dumb. So it's required underscore is ready. And my zombie, just like what they said, but of course, I'm a hacker. I don't follow instructions. And we semicolon that shit. Alright, so we got that done. And, oh yeah, we have to add the my zombie so it can reference it. And, of course, the semicolon. So what I did there was I did the old hacker trick and made this way more complicated than it actually needs to be. I thought we actually had to add a modifier instead of a function. So while I did make this internal, like I was supposed to, what I ended up doing was, if I did everything correctly, we just added the require, the is ready for the my zombie, and then we had to reference the my zombie. Let's see if we did that correctly. Yep, we did. Yay! I am slowly, very slowly learning, which means I'm dying. But we're halfway there, and now we're going to be over halfway there. So let's go into the next thing. No, I don't want to sign in. Now we get to do more function modifiers. Yay! Let's see what they want us to do here. It seems like we're going to add an entire section here. So let's see. So now we have cooldown timer. They're going to add some helper methods. So create a new folder here. So we've been doing a lot with zombie feeding and referencing the zombie factory and the ownable.sol files. Now we've added a new one in the contract that's just called zombie helper, which is going to import the zombie feeding stuff. And that way it keeps our code organized. Instead, for me, it just gives me a headache because I started with Objective-C, so what the hell do I know? So basically, if you remember correctly, we already had a system built into the zombie factory where zombies are able to level up using the whole unit system with the different bit values. So now what we're going to do is as they level up, they gain special abilities because we're trying to really make this into World of Warcraft. But in order to do that, we have to learn apparently about how function modifiers work. So let's see. Previously, we looked at a simple example of the only owner. So apparently these function modifiers can also do different arguments. So let's see. So we can map like a user's age. And then modify that. Requires the user to be older than a certain age. It must be older than 16 to drive. So this is like the whole, like, you know, when you buy cigarettes and stuff. So you can map a unit to be over a certain value. And then you can do an older than and then require, and that's the verification check. And a drive car will then reference that check. So that makes some sense. Say that as the two left brain cells rubbed together. You look very, I get this aura of you being very confused. I don't know if that's Vintage Computer Festival or what to be trying to do this. Both, okay. Because I don't know if you've ever looked at Solidity before, but trust me, it's technically simple, but it's very confusing trying to learn this.
So I am currently writing fourth code for a 512 byte bootloader kernel.
Yeah.
That the entire interpreter for fourth is in that 512 byte bootloader.
Yeah.
It's weird, and I still find this
weird. Yes.
complex.
I think because this is a smart contract language, because as they said earlier, it's really incredibly anal. And it's like very lawyer structured because once you deploy this, you can't change it. So it wants to, yeah.
Do smart contracts compile into a bytecode?
They technically do, but we're apparently not in that stage right now.
Right.
Not that I don't want it to be, because we're going to check at least one more thing before I do the Libra stuff. I just want to get through this because I knew this was going to be the longest part. You could, if you need to turn the fan back on, you can turn it back on. Yeah. I just needed a semi-break to make sure that I'm not crazy. Because I am crazy, I'm just, in terms of this. Let's see. So now we're going to try and make our own modifier that uses the zombie level property to restrict access special abilities. That way they just don't all open at once, and then we'd have to scrap that contract and then open a new one. It's like going to the DMV or something. It's annoying. So let's see. So what we're going to do here, so in the zombie helper part, we're going to create a modifier called about level. It's going to take two arguments. The underscore a level, which is going to be a unit, and zombie ID, which is also just a unit, which means we're not adding like bit values because it's just going to be the 256. So because I am a lazy fuck, I am going to go back to Zombie Factory. And this is the part where we're supposed to add the modifier thing. So I'm going to go in and steal that from here and then modify it. Because let's be fair, most of the internet is just an endless loop of Stack Overflow answers compiled on top of each other. It's true. Let's see. So I have this floating around somewhere. Did they take this away from me so I can't cheat? Or maybe it's under ownable. Here's the okay. This is the modifier. So we're gonna take this. It's too dangerous to go alone. We're gonna take this as our base, and that should work. But we might have to move things back a space. Don't know yet. All right. So we're gonna take a modifier, and we're gonna call this one above. If I can spell it right. Level. So that's it. It's gonna take 2 arguments. Oh, I see what we're doing. Okay, hold on. Now yeah, I can actually do all this. Wow, this goes back farther than most text editors and stuff that I know. That's comforting. So instead of stealing from another part, because my folly so far has been making this way more complex than I thought, because again, I grew up on Objective-C and the earlier versions of Java. We're still going to copy pasta from what they already showed us. So we're going to create a modifier, and again, we're going to call it above level. And we're going to do a unit that is called level, not spelled in leet speak. I'm not a zillennial, so I can't type it like that. And another called zombie ID. So now the body, which is the require, should be that zombies. So we're going to take out the, let's see, zombie ID dot level. Okay, I see how they're writing this. So the way we're going to do this is that the zombies, which is the bracket zombie ID level, sorry, dot level, not spelled like a zillennial, because apparently my E key just doesn't want to work anymore. Is not greater than or equal to the underscore level. If we pass this with flying colors, it means this is going to be the fastest lesson we've ever went through. And of course, even though they haven't explained it to us yet, oh, by the way, real quick, I love how in this whole lesson, they're like, you see the underscore semicolon? We're going to use that throughout this episode, but we're not going to explain it in this lesson. We're going to explain it to you. I'm like, that is such a programming class, isn't it? Yeah. That's a very, like, you know, as I described it, it's like we're going to send you into the apartment building, and then you're going to find the room of lions and get eaten by them, and then we're going to tell you after you're mauled by them, oh, by the way, there's a room of lions. Like, it's that type of, tell you, no programmers wrote this. So let's see if we actually nailed this one. Nope, we didn't. What are they complaining about with me? I did a typo, didn't I? Let's see, so the require zombie ID. Oh, yeah. I wrote it as underscore, so it should just be a lowercase t. I'm dumb. And what else does that have to complain about? Any more spelling mistakes? So require zombies. I bet. Yep. Just 2 typos. Yeah, Spider eventually. Except this thing. We'll explain it later. Yeah, I think this is why programmers have such PTSD, because they already go through this with their parents, and now they have to do this at their job and their hobby. It's just awful. All right, so we only have 4 more of these to go for this lesson, and I don't want to sign up. So now we're going to do zombie modifiers, and I'm not going to say what I thought above level said, because that will get us like shot by the Twitch mods with the banhammer, but let's just say my brain's not pretty right now. So let's see. So we're now going to talk about the above level modifier. We're going to create functions in that with the zombie helper stuff. So we're going to add that below the whole modifier system. So our game will have some incentives for people to level up zombies. So We're going to add in that for zombies level 2 and higher, user can change their name. Wow, that really sounds like Google was something that actually that's what Sony did. Didn't Sony do that? Where like you had to pay to change your name? Yeah, it sounds about right. For zombies level 20 or higher, they can be able to give them custom DNA. So now we're going to implement these functions below. Here's example code from the previous lesson. So it's getting mapping. So we can map a unit to be a unit, and then require that this user to be older than a certain age, like we said before, and we do the modifier for that, and then the whole function thing. So what we're going to do is now we're going to create a function, okay, called change name. All right, so we're going to put that here. So function, change name. We're going to do 2 arguments. So we're going to have underscore. Sorry, we're going to declare the unit first. So unit underscore zombie ID with a lowercase d, and we're going to add a string, which is a underscore new name with the data location set to called data. I can't remember how I do that, so is that a no? Oh, let's see here. Call data is somehow similar to memory, but it's only available to external functions. Okay, so let's see. We're going to make that external. Data located. Maybe there needs to be an equal sign after new name. So we're going to do find out. Close that bracket. We're going to make that external. And we're going to do the above level modifier. Actually reference the above level modifier. So above level, okay, so you put that in there. Capital L, right? Yep. And pass for 2, okay. I see what's happening here. So now we're going to bracket this and do 2 for level. And if I remember correctly, we're going to also do pass the zombie ID. What do they mean by pass the zombie ID? I'm just going to put comma zombie ID in the meantime. Alright, probably screwed that up 5 ways to Sunday. I think we were doing good until that end bit there. Let's go on. Oh god, this is so comprehensive. Let's see. So the functions is going to be the body of it. Verify that message sender is equal to zombie to owner. Zombie ID, we're going to use a require statement for that. Double check. Okay, so we're going to have to do all of this crap here in the body of this. So that's, I don't remember where I put this. That's going to be here. Let's see. So what they want us to do here is that the zombie ID bracket underscore zombie ID dot name. Oh, the dot name's on the outside, folks. Is equal to the new name. Oh, I see what they're trying to do on the top part. So the above level. Now, here's my problem is I don't know if I think we need to add another above level here. We'll have to do this twice. So this is going to be, because they remember they're saying level 20, and now wait a minute. What they want, level 2? For the level parameter. Hang on. Okay, so you do it in the same brackets. All right, so that I see what's going on. Okay, glad I double checked the syntax there. There's no comma. It's just 2, and I have to declare the unit 2 for level. And let's see. And then for down here, we're also going to declare another unit for 20. And that's the zombie ID. All right, I think we just saved our ass right there. All right, so. And then after that, instead of this thing, we need to make this a fucking bracket again. There we go. So I made a curly key bracket. And delete that bracket. So now we're back to the good brackets again. All right, so I think I just saved my ass back there. So let's see. Now we're gonna verify by doing the message sender is equal to okay, so let me see something. So we had to require okay. Find that message sender is equal to zombie owner. So zombies equals zombie to owner. Okay. Oh, I see here. All right, so I think that's down here. All right. So we're going to require that sender is equal to zombie to owner, which is a zombie ID. I think after this, like, I don't care how awesome Resident Evil is on Oculus Rift, I think I'm all zombied out after this. Now we're going to create another function. Great. Name change DNA below change name. Okay, so we're creating a new function. And actually, let me double check something with these functions. Okay, so we are doing them correctly. I think. We'll know when it yells at us. Change DNA. I'm going to define its definition and contents will be almost identical to change name. Okay, except the second argument. Okay, so we're actually going to copy pasta, the top argument here. If I can. Okay. So I just did that. Now we're going to change this to change DNA. So it's almost identical to change name, except the second argument will be new DNA. Okay. So let's see. New DNA, which is a unit. We still keep the zombie ID. But now we're going to change this to a unit. Called new DNA. Pass it 20. Okay, so we keep everything the same. Huh, wait a minute here. So let me just look up to what the previous one was. Okay, I see what's going on. So zombies DNA to new DNA. Okay, so those have to be at 2. Then set the new zombie DNA, the new DNA. Instead of saying the zombie's names, now we're going to go back to the name. And I think we're going to change all the zombie IDs to new DNA. I'm pretty sure I screwed up somewhere here, but we're going to find out when it yells at us. Alright, let's see how much it yells at us. I think it's yelled at us a lot. Alright, so we're going to go back to change name. So let's see. So the first problem is that new name equals called data. And honestly, because I don't know what it is, I'm just going to show the answer for it. String data new name. So it doesn't need this part. Okay. Blah, blah, blah. Above a level. Oh, okay. It just automatically knows it's that. So we don't actually need this part. We just need the number. That actually makes sense in the weird way this whole thing is set up. Oh, right. It's like I forgot everything from the first lesson. After you declare the things, you can just type them in. You don't need to actually, like, represent them again as rigidly as I thought they would be. I'm a genius. So we needed double equals here. And I forgot the semicolon. And apparently it was... Or I say it's perfectly cool with that line. So name equals name. Oh, no bracket. There we go. That works. All right. Now, what is the claim? Well, what is the claim about below? First of all, I have a typo here. It's function, not function, which almost sounds like a certain F word with a ton at the end. And it's a lowercase na for DNA, as I've been typing because I haven't been paying attention. Let's see. It probably has to do with that call data stuff at the end, which we don't, now I know we don't need because I got confused what it meant by call data. And then, of course, we're going to truncate this to 20 and the zombie ID with the comment. Yep. And then there's an open bracket. And then we have to do that double equal sign for the sender. And then zombie to owner. We actually do keep the zombie ID. Lowercase d. And what is it complaining with at the bottom here? So we have zombies with the underscore zombie ID dot. The DNA, right. So we're not doing name, we're doing the DNA. That should pass us. Nope. What is it complaining about this time? Alright. So, same spelling mistake from up here. It's functions. We're putting the fun in functions. And it's just all typos, basically. What does it try and do here? It said, show me the answer. Oh. Yeah, because you close the brackets at the end, because I'm dumb. Let's see, string Oh, that's where you declare the call data. I keep forgetting that they always, in this language, you have to do these type of. All right, let me explain in a moment. So we're up here where I was confused by the set the location. I keep forgetting you have to put the locations above before the arguments. Ah, I told you I'm being tortured right now. I think that should be good. Lowercase z for zombie. Spelled the whole thing wrong. Zombie. There we go. And then, what mistake did I do down here? Let's see. Oh, yeah. Forgot to put in a bracket to close the previous bracket. Wait a minute. Message 2 center double equals zombie 2 owner. Ah, I forgot to put the little, this one. There we go. Click down here. Should be fine here. Let's try again. Okay, so that's fine. Now we just have to make the same corrections to the DNA. Unit new DNA. And then I screwed up zombie again at the end. Being dyslexic, and I keep switching over to BIE, although I'm not dyslexic. And that's not a diss to any dyslexic people out there. It's just literally that's what you do. Is where you, one of the things people talk about is where you kind of switch the letters, and that's what I'm doing because I'm an idiot and I'm tired. Joy. Chat, do you actually like watching me suffer like this? I mean, because I figured everyone would, and that's why I kind of did this. But, you know, I just want to know. I just want to guarantee. I mean, someone just donated money to watch me suffer near the end here. So I'm going to go on a little bit of a break. And then I'll be good. So I don't need these little tiny brackets down here. Right? I do need one after zombie ID. I just want to double check here. Zombies, let's go zombie ID dot DNA equals new DNA, then M bracket closing out. All right, what more do you have to complain about with me? What are you complaining about? More? Did I just screw up capitalization? What's this one? This is the change DNA. Wire. I'm going nuts here. Wire MSG. No MSG! Sender. Double equals. Zombie to owner. Zombie ID. Oh, I do need that there. Please. Yay! Ah. So the easy part is typing the code. The cleanup part, that's the part where they kill you. But the good thing is that we only have 3 more of these to go before I cry in the corner. Because after this, I will be taking a break. And then we're going to go on to the next topic. We're going to see how many of these I can do before I crack. I'm already beginning to crack. So now we're going to save even more of the gas with view functions. So now that we have special abilities for higher level zombies, we're now going to give our owners incentive to level up with them. So we can add more of these later if we want to. And we're going to add one more function, which is our dApp needs a method to view a user's entire zombie army. So we're calling it get zombies by owner, which kind of sounds like a weird book title if you ask me. This function will only need to be read data from the blockchain, so we can make it a view function. So now we're going to be talking about optimization here. Another thing that's never talked about in programming. So view functions apparently don't cost any gas, okay? I forgot previous hour of me trying to learn this shit about gas where it's not just something you get at Chipotle in New Jersey. What it is that everything that you do on a blockchain thing, that way you don't get abuses with unlimited amount of queries, costs something at different values of the cryptocurrency that's on the blockchain to execute functions for and on the blockchain. So you may have seen past episodes when we did things like MetaMask and stuff, or like when we did the coin droids things 2 DEFCONs ago, where we had to pay a little bit in Ethereum token or whatever token we were on, like a point whatever or 0.00 whatever, in order to like update our profile or to move this thing from here to here, stuff like that. That's what the gas is. It's like that's why they call it gas, not just bloated. It's the stuff that you put in the car to make it go. Gas is the amount of cryptocurrency you put in on the blockchain method to make things go, so that it's sort of like an extra validator, which can cause some problems, because what if you have an unlimited amount of cryptocurrency money? Then you can pretty much do anything you want. Gas is worthless. But that's neither here or there. We're just trying to learn some programming stuff. So as we learn here, the view function, or to view certain things within the dApp, doesn't cost any gas, and they're called on by an external user, because the view function here doesn't actually change anything on a blockchain. It's only reading of the data, which, again, we also learned the public, private, internal, external thing in order to know what's viewable and what's not. So if we mark a function with view with the web3.js, so it only needs to query your Ethereum node to run the function. It doesn't have to create a transaction on the blockchain, so basically it costs nothing. It costs nothing. It's socialism on the blockchain. So apparently we're going to cover the web3.js for your own node later, which thankfully we're not looking into now. But now for the big takeaways, you can optimize your dApps gas usage for the users who are going to be playing our zombie game by using the read-only external view function. So now we get to bolt view onto our external functions whenever possible. They say here, if a view function is called internally from another function in the same contract that's not a view function, it will still cost gas. Okay, so it can only be called in by outside users and call in internally. That is a change function on the transaction in the blockchain, so it will have to be verified, so that will actually cost stuff. Now we're apparently going to put this to the test here. Implement a function that will return a user's entire zombie army. We're going to later call this function from a web3.js. We want to display user profile page, but we're not there yet. We're just going to focus on this. So what they're asking us to do here, as I slowly melt into a puddle of goo, is create a new function named getZombieByOwner. This is still going to be in the zombie helper part, so we're going to find that section. This is going to be down here. So we're going to add a new function called function get zombies by owner. We're going to do one argument, which is a address named _owner. See, this is the part I remember from the last lessons. And we're going to make it external view, so we can call it from that. And the function should return a unit. So as a memory data location. This is the part where it's going to stump me here. So we're going to do view. Let me just look at some of the other functions just to remember how I'm supposed to do functions, because my brain hurts at this point. Public. There should be a bracket, and that should be the return part, right? If I remember correctly. Did I remember this correctly? Alright. So let's go back and let's try to do this. So we're going to do an open bracket. Function return a unit. Okay, so we're going to do UINT, bracket. Whoop. You only have to type the bracket once, get 2 brackets. Memory data location. Okay, that part I don't know. So we're going to run it and get an error, but I want to see what the hell is going on. Alright, so one thing is I added an extra space, which I figured. And apparently this whole part it does not need, so what does it want me to write there? Okay, so it's... Oh boy, okay, I see what's going on here. It's zombies by owner, address owner, which we did correctly, external view. Here's the part where everything went stupid. So, yeah, it should return. I keep forgetting that we actually have a command called returns. And note that, like I made the mistake last time, it's plural returns, not singular, because there is actually a difference. We're going to close that unnecessary space. We're going to do, so that's the unit. Do the brackets, space, whoop, after the brackets, memories. Just like that terrible recently butthole cut movie. So MEMORY, and then we have that. And there should be nothing. It should be cut off at that point. So there should be nothing inside, just like my soul. Double check. This is all kosher. Should be a gap though. Okay. Yay! I think that was the easiest one that we done because again I forgot the whole return function thing. I keep forgetting that this entire thing. Onward. No, I don't want to sign up. Alright, so we're going to learn something that I've said on previous episode of Crypto Barons, which is that storage is expensive. As we've covered, not all gas is created equal, as we know from eating at various fast food places and diners in New Jersey. As we mentioned before on here, writing to storage, so writing actual data to the blockchain, is reading it's already costs a bunch of gas. Writing it is the most expensive thing you can do. And this is because every time you write or change a piece of data, it's written permanently on that blockchain forever. So that's permanently on each block in the node. And thousands of nodes across the world need to store that data on their hard drive so it can do the whole self-check reference system. And as it keeps growing, blockchain grows because it's more complicated. Therefore, that's why it's the most expensive thing to do and costly thing to do. So in order to keep costs down, we're going to want to avoid writing data to storage except when absolutely necessary. Gee, this sounds like the Vintage Computer Festival stuff. It's funny how things don't change. Or we want them to change, but we keep circling down the drain. So let's see. So sometimes this involves seemingly... This is a great sentence. Sometimes this involves seemingly inefficient programming logic. I'm waiting for someone to create a language called inefficient programming logic, aka every programming language ever invented, yes. Like rebuilding an array in memory every time a function is called instead of simply saving that array into a variable for quick lookup. In most programming language, looping over a large data set is expensive, but in Solidity, by the way, anytime you're learning a language and they're like, other programming languages do this, but in our language, prepare for the bleeding from the butt levels of things they're going to explain. Like, I already know this, not reading the rest of the sentence. It's, that whole thing of like, well, in other people's countries, they actually get paid for things. But in our country, we pay you in rocks. It's like that type of shit. Let's see. There is a way cheaper than using storage if it's an external view function, since view functions don't cost anything for any gas. Okay, actually, that's a good thing. We're not going over for loops. Thank God. We're not doing for loops. Thank you, God. Because I literally just got worked back to high school programming classes just by reading for loops. That's why one of the reasons why I get slightly triggered when I see fruit loops. Just putting it out there. So now we're going to do what they said, which is the pain in the ass they're going to do, and declare arrays in memory. Let's see, we're going to use the memory keyword with an array, create a new array inside of a function, and ate the rat that ate the bolt that lived in the house that Jack built. This array will only exist until the end of the function call, and this is a lot cheaper than gas-wise than updating any array in storage. Free if the view function is called externally. So here's how we can declare it, and it looks annoying. Function get array external pure. So literally, this is the bullshit chapter. We're doing a bunch of bullshit just so that we can program around stupidity by programming more stupidity. Because we're now going to array a unit called memory. We're going to put in an array and return the values. This is great. This is a trivial example showing you the syntax, but next chapter. Oh, they lied. I thought they meant the next lesson. The for loops are going to be in the next chapter. It's false hopes. Memory arrays must be created with the length argument in this example 3. They currently cannot be resized like storage arrays can with array push, although this may be changed in the future version of Solidity. We hope so. So let's see, in order to get let's actually see which part where we're going to have to put this in. It's probably all the way at the bottom, right? Yeah, get zombies by owner. We're going to return a unit array with the zombies, in particular user own. So we're going to declare unit memory. What's the syntax again? So we're going to values result equals. That's the way to do it. Memory value variable called. Hold on a second. Unit memory values equals. Hang on. Unit memory variable called results. Yeah, we did this correctly. Set it to an equal. Set it equal to a new unit array. Oh. There's where we put results. Hold on. Think. After equals, and do a new unit. The brackets. The length of the array should be however many zombies this owner owns. We can look that up from our mapping. Owner zombie county owner. Okay. Wow, they're really making this con. Okay, shit. Ah! Let's see. The zombies owner has mapping. I'm trying to remember how we did mapping. Oh! Honestly, I could probably eat like a Frozen thing or listen to the song Frozen, and the headache that follows will be a lot better than what I'm doing right now. We're gonna file under this on the bullshit that I do for charity, as the Hot Pockets were done there for a second.
Battery in the rope side.
Yeah, I was thinking of that too, because I'm like, didn't used to work on like all angles, and now it only works at like one angle. Jeez, that was unexpected. Okay, so mapping. Marsha. I'm just gonna copy this from here. So, new unit. All right. I think we might be able to do this by doing owner. Think, and then we should be able to add mapping down here. Oh, I see what we're doing. Hold on. Let's go back to this. So we are doing things in the bracket. But first of all, this bracket should be empty. And two, we'll do this. We should do or I think. I'm just going to type this in and pray for the best. Probably makes no goddamn sense, and it's going to yell at me. Or is that what the... Maybe what we're supposed to do. God, I can't... Alright. You know, here's an idea. We're going to smush this down to owner. Alright. Semicolon. And then the body of it, we're going to copy pasta the mapping again. Except we're going to do it like this. Actually, we should change this to owner zombie count. The mapping system down here. And we're going to do the return. Oh, I need a vacation after this. So this is going to be empty, but Now I'm going to get yelled at, so here we go. Yep, all the yelling. What's going on with all the yelling? So it's mad at the mapping thing. What does it want me to write? First of all, the unit mapping. So just the results, the S in results. Need the Okay, so why doesn't it want that at the end? Oh, so we had to put in the owner thing. Okay. All right, that sort of makes sense. But now, what's this garbage down here, I think? Oh, and then we can... Oh, because the mapping already exists, so we're just returning the results. Yay! It's supposed to be one long string. I got confused because we already did the mapping at the other thing, therefore it didn't need to be called that. It just needed to be called that within the actual whole memory value system. 2 more to go. No, I don't want to sign in. So now we get to the dreaded for loops in which I get to finish the last bit of liquid, which is a representation of my sanity during all this. I think I've been literally doing this for an hour at this point. Yep, been doing this for an hour. We might stream until midnight, I don't know. We're gonna find out. Like, if I knew this was gonna, I figured this was gonna be trouble, but I thought we'd get through this in like a half hour or 40 minutes. If I knew this was gonna be this much of a brain teaser, it definitely qualifies as the advanced part. I would just make it about the advanced things, not deal with everything else. But someone already donated money, so at the very least, I'm gonna do the whole Libra stuff because I promised that. Unless it becomes like a 24-part chapter thing, then I'll do the beginning part and be done with it. So let's see. So sometimes you can use a for loop to build the contents of an array in a function rather than simply saving storage array. Let's look at why. So for our get zombie owner function, get zombies by owner function, the one that nets all the zombies together. Native implementation would be to store a mapping of the owners to the zombie armies and the zombie factory contracts. The whole mapping thing down there, the address equals or greater than unit, and that addresses the ownership publicly. And every time we create a new zombie, we would simply use the owner to zombie number with the push zombie ID, add it to the owner zombie array. So everything is basically just done on reference instead of writing everything to the chain. And then get zombie owner would be a very straightforward function. We get zombies owner, address, owner, external view results, unit memory, all of that, return owner zombies. So why don't we do this? What's the problem with it? The problem is that I decided to do this tonight in the first place. But no, the approach is tempting for its simplicity, but if you look at what happens if we add functions to the transfer to a zombie from one to another. So the transfer function would need to push the zombies to the new owner array, then remove the zombie from that array and shift every zombie in the old owner's array up one place to fill that hole and reduce the error. Oh, I see. So this whole thing would be rigid, and you'd be doing so many different transactions on the blockchain that, yeah, it would be expensive, especially for the gas stuff. You have to write for every zombie is position shifted. So if an owner had 20 zombies and they traded with the first one, they'd have to do 19 writes of memory in order. So that's 19 whatever the gas is. So yeah, that would definitely add up. Writing to storage is one of the most expensive things in Solidity. Yep, we just covered that. So let's see. Since view functions don't cost gas when they're called externally, you can simply use a for loop in the get zombies by owner to iterate the entire zombie array. I can actually feel myself gaining bags under my eyes reading this. I guess I'm a real developer now. To iterate the entire zombie array and build an array of zombies that belong to this specific owner. I'm actually shocked Jack is still up. Then our transfer function will be much cheaper since we don't need to reorder any arrays into storage, and somewhat counterintuitively, this approach is cheaper overall. So we're going to do this. Here's a sentence I never want to read. You see this? You see this in chat, this sentence? This is the biggest red flag. You can send me on everything. The syntax of for loops in Solidity is similar to JavaScript. That's the equivalent programming sentence to I'm pregnant, you're the father, and I'm gonna kill all three of us. That's the and looking at the stuff that they want to see as an example, yeah, geez, where's the part where we're gonna do this? Let me just scroll to that section. So at least this chunk we don't doesn't seem we have to change anything. It's just gonna be between the whole new unit declare and the result. Let's see, it keeps a track in the new array. Unit counter equals whatever 4, and then we do a bunch of operations. So to iterate 1 through 10 with a for loop. And then if it's even, you have that result and you add that to the array. Increment counter to next index. God, this is going to kill me. That would return that array result 2, 4, 6, 8, 10. The winning Powerball numbers. All right. I think this is going to be, I have a feeling we're going to be done probably after this, because usually the second to last or last thing is more of the like, look at what you accomplished. So I think this is like the boss challenge. I knew I heard boss music for a reason. This is it. This is what we're doing this for. So let's see what they want us to do. So we're going to write a for loop that iterates through all the zombies in our dApp, compares their owner to see if we each have a match, and pushes them to the result array before returning it. So we're going to declare a unit called counter, set it equal to 0. So that's going to keep track of the results. So we're going to declare. Okay. So it's just like above. As Cell does the thing I really want to do and go to sleep right now. I heard it was extremely active at the Vintage Computer Festival. And remember, I could be out partying right now. I could be doing so many different things. I could be playing video games, but I am torturing myself, not only just for you, but for charity. So that should tell you how dedicated I am with all of this. So we're doing that. And then we're going to declare a for loop that's unit I equals 0 and goes up through I lower than the zombie length. So this will iterate every single over every zombie in our array. Okay. This is going to be the for loop here. So we're going to do for. Oh, no, wrong brackets. There we go. Uint I equals 0. Okay. And then we're going to do this all the way up. No, equal sign. There we go. Or is it just, oh no, it's no equal sign. So it's just that plus the zombie length. So that, I plus plus. And then we're going to open all of this and do our actual looping. So inside the if statement, oh god, this makes my brain hurt. Don't make me do stuff. So our if statement, we're going to add the zombie ID to our results array by saying the result counter equal to run. So result counter equal to I. Oh, I see what's going on. Oh god, this is annoying as hell. Let me just do these brackets. Set that down there. So if do that bracket. So I skipped that step. I forgot this was over here up there. So if zombie to owner I is equal to owner, right? Just like it was processed up here. And then we're going to do the results counter, which doesn't need these tiny brackets here. Do that. And then we can increase the counter by 1. Plus plus. And then there should be an M bracket here and an M bracket there. And then a return. Or, aha. Actually, let me close this. Okay, da-da-da. All right, please. Okay, what is it complaining about? Zombie to owner. What does it want me to write? I had to do 2 equals. Ah, forgot about that part. And I forgot to put the semicolon. Other than that, we actually did it. So besides the 2 typos, I actually typed it exactly the way they wanted to. Yay. Holy crap, that's insane. So we basically got through this. Holy crap. That concludes the lesson. We made it, folks. We made it. We got through advanced Solidity. We did arrays, we did for loops, we did viewing, we did all of that, and I lived as I slowly go nuts. So as a recap, we figured out how to update the contracts, in this case the one for CryptoKitties. We learned security functions by using the own the owner function and to verify that owner. We learned about gas and gas optimization. We added levels and cooldowns for our zombies, and we now have functions to update a zombie's name and DNA as perks when they reach certain levels, and now we have a function to return a user's zombie's army. So we now have an reward for lesson 3. Both of your zombies have leveled up. And now that no name, the kitty zombie you created lesson 2 is upgraded level 2, you can call change name to give her and her name, no more. Go ahead and give no name a name, then proceed to the next chapter to complete the lesson. So I don't know what we should call our zombie now, even though I'm not registered for this, and I'll probably have to go through all these courses again on my own account. But I'm just gonna call them. Actually, no, not TCG211. Let's call them Cactus, because that links to my whole phone losers thing. So we're gonna call them Cactus and save. Yay! So unfortunately, the save didn't work, but now we have our own random custom zombie. And we're going to now share that on our Twitter. This proves that we actually did all of this. We're going to share this on our Twitter. Yay! I'm going to call it TCG201. Yay! And I'm just going to share this hilarious tweet. So we did it, folks. We got through it. We lived. We survived. Holy crap. But unfortunately, or fortunately, actually very fortunately, we must thank Binary Badger for donating some money. I don't know if GG means you have to go, but we're calling you out that yes, you did donate $20 so far as a reminder for the audience that I'm not just torturing myself because I like to get tortured, although if you pay me enough, I do like that. We are trying to raise money for the Children's Miracle Network Hospitals, which is a whole charity that's nonprofit organization. They raise funds for children's hospitals in the United States and Canada. And all these, especially children's hospitals and children's wings of hospitals are incredibly understaffed, underfunded, under everything, and under the thumbs of bad government and corporate and individuals' decisions. Yeah, well, you're going to torture me more, right? So a lot of the money is going to be dispersed through all sorts of children's hospitals around the world, but across the United States and Canada. But thanks to our friends at Child's Play here, we are particularly going to be focusing on the Children's Specialty Hospital, which is an RWJ Barnabas Health facilities, and they're the nation's leading provider of inpatient and outpatient care for children who are born all the way to 21 years old. And once you can drink, goodbye. Just like that should be really the motto of New Jersey. If you can drink, goodbye. But they treat everything from chronic illnesses to physical disabilities to diseases such as the current COVID plague we have going on right now, and mental health stuff and more. And they're at 14 different places in New Jersey. And so a bunch of the money that you will donate that we're going to be raising until November 7th, we're trying to reach $600 by November 7th or earlier. If we reach it earlier, we'll up it even more. But we're trying to raise a thing of 600 by November 7th, and a bunch of it's going to go to these 14 different hospitals across New Jersey because we're the New Jersey group. And then a good chunk to the rest of the money, especially extra money, if we can get more than 600, will just go to children's hospitals all across the United States and Canada. It's like children are already going. We're already going through enough as adults. Never mind like all these like kids who are just going through the worst stuff. So here's what we're going to do for now. I'm going to go back to the face cam while we do this. I'm going to take a short break. I'm going to put on some of the music that you heard earlier. I'm going to go cry, because I can literally see, like, I didn't have these bags underneath my eyes when we started. These grew by learning more advanced Solidity. So I'm slowly turning into one of those development assholes. I mean, I was already an asshole, but now I get to add dev asshole under my belt, along with being a staff member at Radio Statler at the Hackers on Planet Earth conference every year, except for 2020 because I got way too busy, but at least I got to give them End Commander, so that was great. What was I going to say with this? So, I'm going to go on a break. We're going to put on some music, and you also might hear Sir still snoring in the background because, man, did he and End Commander had a day. They're probably going to tweet about it at some point. Hopefully, we'll get a Circuit Breaker episode about it. But I'm going to go on a short break. I'm going to rehydrate. I'm going to cry and rethink all my life decisions. Then we're going to come back, and we depending on the thing, we might do at the very least, one more of these crazy lessons, because I didn't expect, as she said, I didn't expect it to be that long. Wink. Wink. But at the very least, because Binary Badger donated, actually, I'll say this, if I'm on break, the more money you donate, and I'm going to put the link in the chat because the Tiltify is not up yet for Twitch, and I will add that in a moment, but here's the charity link. Even if it's like, I would say, I'm not even thinking of $1, like if you send like $5, the more money you add to this during this episode, each individual donation, I'm going to do another lesson, and my limit's going to be doing 3 more of these before I get to the Libra stuff. So because of Binary Badger, I'm definitely going to do the Libra lesson because I talked about that right when they donated. But we're going to check out we're going to try to check out one more episode before that. We're just going to see how I feel. But regardless, I'm going to go on a quick break. I'm going to put on some cool chiptune music or something that is completely like free to use sort of stuff. And hopefully when I come back, maybe there's $1 or $5 donated. I put the link in chat. If not, I'm going to continue on. We're at least going to do the Libra stuff. Then I'm going to distribute all the lemons. And we're going to go raid the channel on Twitch. And that will be that. So stay tuned. Enjoy the music. I'm going to be right back. And like, stare at the abyss and have it stare back at me and call me by name and feel very sad. So enjoy the music. I'll be back in like a minute or 3. Hello, everyone out there again. We are back. For those who may have came in from a break, and then I'm going to read. Binary Badger's comment here. But I'm Sidepocket. I'm one of the two co-founders of DCG 201, formerly known as DEF CON 201 or DC 201. We are one of the many DEF CON groups that are across the United States around the world, and we meet. We do a hacker gathering now as hybrids, both in person and online, every third Friday of the month. In fact, our next meeting is going to be on October 15th, so that's this upcoming Friday. And if you want to know more about us, you can check out our website below or the link I put in chat at defcon201.org. And if you want to check out on social media such as Twitter or Instagram or GitHub or Mastodon or any of that, here's also the master link of all the different social media links we have. Finally, that I want to put out there is that all this month from now until November 7th, you can hear how tired I am with everything going on. I'm not just torturing myself today and feature episodes of this live stream just for shits and giggles, although looking back, it's always really funny. We're actually trying to raise money for the Children's Miracle Network hospitals, which support all sorts of children's hospitals across the United States and Canada. And of course, a lot of these children's hospitals are understaffed and underpaid and under equipment and under people's thumbs and just all sorts of terrible stuff. And most everybody is going to go through multiple members of the Children's Miracle Network hospitals, including thanks to our friends at Child's Play, not to be confused with the popular horror series, which is appropriate because this is spooky month. But we are especially focusing on the children's specialized hospitals, which there are 14 of in New Jersey, which is where we're from, that specifically treat children from birth 21 years of age from things like chronic illness to physical disabilities, mental health issues, behavioral and developmental issues, diseases such as the current COVID plague going on right now, and many other things. So if you want to help out not only children in New Jersey, but children around the world, definitely go donate to our charity. It doesn't have to be a lot. We're aiming for $600 by November 7th, but everything adds up. When we do these sort of charity live streams before, most of the donations really add up from people literally donating like $5 each. So if you're interested, you can either scan the QR code or check out that link through Tiltify. This is all handled through Tiltify. We don't touch any of the money. That way everything's all kosher and stuff. And as you can see, when you do, you get a little notification, and we kind of cheer you on. And we sometimes do things like what I'm doing for Binary Badger, where we're going to go through the Libra stuff in a moment. I also want to mention that, again, I love talking with chat. So if you have any questions, comments, and chats that are not completely pants-on head stupid, let us know in chat. But if you're also just here to lurk and learn, keep lurking and keep learning. Finally, I just also want to mention that if you like the content that you see so far and you want to get reminders for our upcoming meeting on the 15th or the big giant special that I'm going to announce at the end of the episode on the 16th. And we're going to stream, by the way, to about like somewhere between 12 and 12:30. That's when I'll distribute the lemons on DLive, and we'll go raid a channel on Twitch, and then that's all she wrote. But we're not there yet, because I still have to do something for the awesome $20 donation that Binary Badger did tonight, because he loves to watch me. I don't even know what gender they are. What they want to see me be tortured, because I guess I'm the new N commander now in terms of getting tortured. But if you do like this content, you can follow us for free on Twitch, DLive, or YouTube. When you do, we also get notifications of that and cheer you on. And especially if you're on Twitch, once we reach over 1,000 followers, we can both update Twitch and DLive at the same time. And again, it's completely for free. Every time we go live, you get reminders for it. It's just fantastic all around. So I just want to quickly read Binary Badger's comments, since he's the one who donated. He wrote while I was away. He wants to give an update about the Lockpick Extreme Practice Locks, because he also watches my other show, Master of Unlocking, which will come back at 8 p.m. on Sunday, the October 17th, because I do first and third Saturdays every month. Seems solid. I'm glad I got the repinning kit. They seem kind of easy. I can single pin or rake all of them reasonably quick, and I don't really have much experience practice picking. For reference, I'm using the toolpick kit they sold. Okay, so using the toolkit, it's as long as you use any picks, you're fine. What I want to know, and tell me in chat, is roughly on average, and here's the thing, when you pick and you get it open, you need to do the same lock like 3 or 5 times just to make sure that the first time you picked it open, it wasn't a fluke. It's also interesting because the Lockpick Extreme ones, they all have different biddings. The tool ones, before the extra pin that they add, each one's the same before. So if you already did 2 pins and you're on 3 pins, you already know the first 2 pins and you're trying to figure out that third pin. So usually I overall find, not for myself, but for others, that the Lockpick Extreme practice locks. I'm sorry, we're going to Master of Unlocking for a moment here. We're going to go back to coding in a moment. But I usually find them like a more difficult way for the beginners to go because each ones have different bidding. So if you pick the 5-pin and 6-pin lock multiple times, like 4 or 5 times, tell me what's the average amount of time. If so, you're probably going to want to move on to a real locks. And definitely you want to include, you can start off with the master lock number 3s and stuff like that, but you're ready to move on to real locks, and that you should also probably go on to Tool or Sparrows and get some of the stuff you can learn with security pins such as spool and serrated, because once you know basic pins, like I can also breeze mostly through 9-pin, sorry, 9-pin, that too, but 5 and 6-pin locks, single pin picking, and not even raking, because raking, you should be able to rake all of them, no problem. But single pin picking, we're focusing on. If you can do it in a couple of seconds and it's just instant for you every time, learn security pins next, and also go to real locks. A minute max. That's pretty good. See if you can get it down to a couple of seconds. See if you can do it. Try to get that down to like 30 seconds. And then once you have it between like, I would say 10 to 20 seconds, then you're truly ready to move on to, well, at this stage you can move on to real locks and try it, but once you get down to 30 seconds for 5 or 6 pins, and keep doing them over and over again, you're ready for real locks, 4 pins and up. And at that case, once you get it down to like 10, 20 seconds, you're now really down for like the security pins, such as spool pins, serrated pins, paracentric keyways, things like that. But let's get back onto the show I'm doing now. It's Crypto Barons. So for all of you who had missed previously what's going on, because it is spooky season again, last month, we covered cryptocurrencies and blockchain check on the dark and deep web. And we also covered the ups and downs of the Brave browser. But back in February, we found this really cool learning platform where you get to make decentralized apps, or dApps, via doing all the by learning how to build this simple zombie game. They're called crypto zombies. And we did the making the zombie factory, and the zombies attacked their victims last time on a different browser. And so I just tried the advanced Solidity concepts, and it kind of kicked my ass. So what I will say is, based on what I've seen so far, honestly, it's kind of streaming really late now. So sadly, we are well, good news, I'm definitely going to be repeatedly returning to crypto zombies in the future. Maybe even the near future. We might come back to this as soon as December or January. But what I'm factoring in is the fact that Binary Badger did send me the $20. So originally we were going to do a bunch more than these, but I think we'll cover this for another time. So we'll leave the app front ends web3.js for another time. We're going to leave the 2 truffle ones, the testing smart contracts and deploying them with truffle, for another time. We're going to leave the Binance chain and the Z-Sync for another time. We're going to get right to the point and kind of end the stream by doing the thing I was going to hate the most, and this is learning about Libra. Now, we covered this both back before it was called Libra, when Facebook called it DM, and it was deemed terrible, and then they changed the name to Libra, and basically all they did was slap a new sticker on it and change 1 or 2 minor factors about it, and it was just freaking terrible. It was still awful. We ran some test networks on it, and it's just totally centralized, evil piece of crap. And I guess one of the things that was announced was, because since it's its own platform, Crypto Zombies has a whole thing about Libra. So as it says, this course will teach you the absolute basic knowledge of Libra by walking you through setting up a shop where the hero can buy goods as a shopkeeper in the game of Crypto Zombies. Walk you through how to set up accounts for the hero and the shopkeeper, how to send money between them, the Libra token, and how to track the status of those transactions, all while interacting with a perfectly accurate simulation of the Libra testnet. Which is nice, because it was a big pain in the ass trying to run that testnet in the first place, especially with how much resources it hogged. So again, what I like about Crypto Zombies is the fact that you can do all this stuff and like doing like simulations in terminal, the compiler, and it's all in browser. You don't have to load any external programs. You don't have to load up Mirror Mask or load up like VS Codium or Visual Basic or anything to work. It's all in browser, and with this whole game thing, I kind of love it. Binary Badger says, I'll time myself, curious how quick I am. Thanks for the update. Now, Spooky Facebook. Yep, here we go. So we're basically, what this is going to be is this is going to be nothing about programming from what I understand. We're going to learn the back end of the programming on Libra like we covered in previous episodes, but we're going to entirely do it through terminal commands, which is the other thing I hate, even though I'm way more proficient at that than programming. So, but it also depends on what operating system they're using. I don't know if they're emulating this after Ubuntu Debian. I don't know if they're emulating this after Pac-Man or Fedora system or Chocolatey or Mac Brew or whatever. So we're just going to start the lesson and find out. All I know is that there's 10 entries for this. We have a nice little like testnet emulated terminal here. And here we go. So just checking all of my stuff before I move on. Okay, I think everyone can hear me. We're good. So the first thing we're going to learn is how to become a shop owner. By doing this, we're going to learn the command line interface. And then we're going to learn how to install it ourselves. So just like bank accounts in real life, as a shop owner, you'll need to create an account on the Libra blockchain before you can sell any goods. Creating an account is free, and create as many as you like on a single wallet because this is a test net. We're going to get into technical reasons for why it's possible next chapter, but the closest analogy is that an account on the blockchain is like having a debit card. You can apply for as many as you like. As we know, for a lot of people are in debt. We know that because we're down in the Libra percentage sign. That's the command prompt for the Libra client, which is sort of like its own command line system within your command line. It's the official way to connect to the testnet. So that's the start of every line, is that Libra percentage sign. And it's automatically there every time you enter the enter key, so you don't have to keep typing it. And so now that we're connected, let's create an account. So I think it's because of how zoomed in. Normally this is all one line, but because we're zoomed in, it like fractured the line. So just pretend this is the same line as the Libra percentage sign. So we're going to do account create. So that's receiving the wallet, and it just spit out a whole account address, right? Wow, this is going to probably go by really fast. So the account number is the index, which is saying that's the position in the wallet. If we create a new wallet, let's see if we can actually do that here. It should go up to #1. Or not, because I think this is just an emulation, so yeah. Account will register on Libra blockchain, so it's just some money in the address. We're going to learn how to do that in just 4, and the address is a hex string. Again, this covers even the first episode where we actually created a blockchain for ourselves, so yay for that. We actually might be able to blow through this, although that might be me putting my eggs in my basket. I'll put it this way. If we blow this, you know, full, like, head to shaft, everything, in the next like couple of minutes, I'll do another programming concept or an advanced terminal thing just to appease the god. Because right now I'm doing this because of the awesome donation that Binary Badger did. Because I thought I would get maybe like $2 at max. They sent in 20. So really, thank you so much for this. Now I don't want to. We're gonna keep doing this. Now we're gonna make an account for the hero in our crypto zombies game. Right. So it's like guys fighting all the zombies and stuff. Since banks don't exist yet in crypto zombie world, I also have to create accounts for all the customers. So we just created the kind of storefront thing, the account, and now we're going to create one for the different players. So we can do that. Same line as chapter 1. We're going to do account create. So that may create a number and address and spit all that out. And now we can see the index for the new account. Okay, so that was account 0, so let's try that again. We should be able to do 2 accounts now. Yep. So as I said before, if we did another account, which now this will let us emulate, it always starts off as 0 as a number. And a lot of programming stuff, for some reason, 0 starts off as its own number, even though it's supposed to be nothing. So we always starts at 0, and then there's 1. So technically, if you have something that's number 10, you actually have 11 accounts in the system. So that's that type of bullshit Unix stuff that Richard Stallman is responsible for, needs to be dragged out and shot. So just remember for that. So we're going to create 5 new accounts. So I guess this is us doing the muscle memory. So I wonder if there's going to, actually, I wish there was a thing like account create time, like *5 or something like that. Instead, we're just going to do 2 more of these. And actually, I want to try something funny. Oh, it doesn't emulate that when you do the arrows up and down that it does your last command. So if you actually were doing this in a command line and you had to do this individually instead of typing over and over again, you could just hit up, enter, up, enter, up, enter, and constantly generate this stuff. So now we have 5 accounts. We check the answer. Yay, we triumphed. So let's continue. They said this took 30 minutes to an hour. Maybe it's because I'm used to command line stuff, but like either that or they're giving me a sense of really false hope and we're going to do something really complicated soon. So now we know how multiple accounts work. So let's say that the protagonist of our game wants to come in and buy like a new sword and a shield to fight the zombies. So we have to give him an account number. Since he's our first customer, you have given him the account with index 1 because 0 is going to be our account that we're going to assign. So there was a hex string that was printed out, but we don't know what it is. So in order to find out about all the current accounts, we can just do account 2C's list. That should list the 2 accounts that we have there, 0 for us and 1 for the new generated customer. But we have a new thing here, which is the sequence number. So we have the account index and the addresses. But what's the sequence number here at the end there? Both 0, even though there's 2 separate accounts. So sequence number is the amount of transactions those accounts have done. Since no one has used those accounts, that's why both of them are at 0. If I gave something to index 1, my sequence number would be 1 and theirs would be 0. If they exchange Libra to me, then we would both be 1. And then if he paid more Libra as like a tip, then he would be at sequence number 2 and I'd still be at sequence number 1 because I haven't done any transactions yet. And the sequence number is a security measure to keep track of how many transactions. So that way, if it says 1 transaction, but then their own account says another, that either means that the chain recording is false or the user's making shit up and needs to be shot. So as someone said here, let's imagine a malicious customer who has 10 Libra in his account. The villain could send 10 Libra to your shop to add and to another shop at the same time. Without a sequence number, the Libra blockchain could in theory possess both transactions at the same time, even though the villain doesn't have 20 Libra. So that's a way of like double spending, essentially, or triple spending. But with the sequence number, we can have track of that. So the blockchain will reject the true transactions with the same sequence number. The customer needs to send transaction sequence, and the second one would be rejected due to the lack of funds, and so thus the malicious actor is thwarted. So yay, we learned that lesson. We're kind of breezing through this. Let's continue. I think they're just assuming that everyone's like a sad Windows user or like a sad basic Windows user as opposed to a power user and has no concept of what terminal is. With so many PPU maps and hacking, that's becoming a lot more common even on Linux. So I think that's why they say it's going to take like an hour or whatever. So let's see. In this chapter, we're going to learn how to fund our own owner address. So we're going to basically add Libra. So the current Libra coin on the test nets have no real value. That's why it's called a test net, which is why we can make mistakes, make stuff up, and just like who lies it anyway, or like the integrity of our voting process not under Trump. Nothing has real value and the points don't matter. So on the main net, Libra is created by validators. But on the test net, we can just generate this stuff. So we're going to just mint things. So we're going to type an account. We're going to mint, and it's going to be account number 3. And we're going to do 300 Libras. Oh. Account mint 300. What the? Okay, what's going on here? What are we doing wrong? So, ACOUNT mint 300. Actually, let me leave that there because they might ask us to do something different below. Hit the shop owner. Oh, we have to the shop owner. So that's his account number 3. We needed to do it to the original one, which is 0. And now it's done that. And we succeeded, but I want to read this. The Libra coin market cap is currently a 64-bit unsigned integer. So if you mint too many coins without any checks, it can exceed the maximum limit. This will not be a problem in production Libra because the coins will be backed by real-world currencies, which is why it's a centralized blockchain, as we covered it on our episode about Libra. And thus minting will be correspondingly rarer but far more costlier, unless some clever hacker does something, because as we know, all of Facebook's source code and inside trader stuff was posted online. I wouldn't be surprised if that happens to Libra soon if they launch it, which don't be surprised if Libra gets delayed because of all the whistleblowing stuff. Just saying. Oh, I have to do it for 1. Hold on. Oh, then we have to put it in the hero's account. Let's try this again. Yay, we figured it out. Next chapter. See, we're just blazing through this. What time is it right now? Hold on, let me check some things. Yeah, we're going to hit midnight by the time we're done. Oh, boy. So now we're going to learn how to pay for items. So now that we have the Libra on the test net for both us as the shop owner and the customer, so that way we could actually do exchanges. Now let's say our hero wants to buy a shield. So that's going to cost 75 Libra. But after we haggled, I've agreed to sell him for 50 Libra, maybe because he has a hot girlfriend. I don't know. Or just girlfriend. Doesn't have to be hot. I'll take anyone at this point. As long as it's not one night in the sack with myself, I'm good. Hero doesn't know how to use his account, send you Libra, so we're going to teach him. So we're going to do transfer. So we're going to do transfer 1. That's their account to our account 0 and 10. So what's happening here is we're going to transfer from his account, which is his account number 1, to our account, which is number 0, and then how many Libra, which is 10. And here's the thing here, is that what about with gas, like we talked about with the advanced Solidity stuff? So on Libra, there is a transaction fee every time that happens. That is gas. Every time we say a transaction, you can set a desired price per each gas and a maximum amount of gas you're willing to pay for. The validators will prioritize higher gas transactions instead those a lot faster, like we covered in our Libra episode. So on the test net, it does not matter, but on the main net, they would avoid paying excessive gas by using a layer 2 solution that's gas free, like the base chain. So in this instance, we're going to send 50 Libra as we haggle with the sort price from his account, number 1 to number 0, and then 50 is our amount. And now we just transacted the 50 over, and success! Man, I was dreading this, even though I hate Libra, but ironically, the thing I hate is actually the easiest thing to do because I'm so used to terminal foo. And we already covered Libra twice, even back when it was called Libra. Before it was called Libra, it was called DM, which was also a stupid name, even stupider than the current name, and more stupid, I should say, stupider. But yeah, we're just breezing right through this because it's terminal stuff, and I know terminal stuff, and I know test nets as opposed to the Solidity stuff that's driving me crazy. So we might do one more extra thing before we go tonight, or we might just end it on a high note here. I feel like Binary Badger's disappointed because I think his whole thing was he was going to send $20 and then watch me like truly suffer, but this has just been easy so far. So we're now checking if the transaction went through. We can query the sequence number to see if it's been sent by the validators because the sequence number should just increase by 1. So we could do that in 2 ways. We could query the accounts or just query the sequence number. So let's do the account first so we can look at just all the accounts directly. As you can see, we have number 100 accounts and the unique hashes for them. And then over here, again, they sent us something, so we haven't sent anything back through the Libra. So their sequence number is 1, and ours is 0. Ours were also 1, but it was before. If someone else's was 1, but it was before ours, it would confuse everyone. Yeah, no, I did suffer. That's why I'm thinking of ending on a high note, especially since we're close to midnight and I want to raid someone properly. See, the other way is we can query everything. So we can query sequence, and the first sequence, which, counting and programming is 0. Nope, hold on a second. Did I type that wrong? Or I think it's 2 spaces. Hang on. Or not. Okay, why can't I do this? Let's copy pasta and see if we'll do anything. Oh, we actually probably have to... Actually, I wonder if this command works. Yay, it actually works in real life. So if you want to make everything tidy and you don't want to see all the previous information, you type in clear and it does that. I also wonder if the double A thing worked. That actually probably could have worked. I actually kind of want to go back to that second lesson where we had to generate 5 times and use the double and, which allows you to do another duplicate command and then just do one string that does all of them at the same time. I wonder if that works. So, let's see. So both methods. So why is the previous methods not working? So let's see. Let's try the account list first. Let's spell it correctly. What? ACCOUNT list. Why is nothing working now? I am confused. We just did it correctly before. Maybe we're supposed to add the @ sign? I was just saying I'm good at the terminal foo, and then all this happened. What do you want me to do? Okay. Oh, I can't do the previous one. So query sequence. Oh, we have to check the transaction that increased by 1. That's why it wasn't working earlier. That was supposed to. Hey, what's going on? Sequence has sequence number of 1 by using both methods. Okay. What's going on? QUERYSEQUENCE 1. Why is it not working? Show me the answer. Look, I'm copy pasting your answer in here. Or not. Hold on. I'm copy pasting your answer. And it's not working. So why are you telling me this? What is going on? Why are you not doing anything? Actually, here's an idea. I'm going to type in you and just replace you with 1. Is there a glitch that just happened? Hold on. Actually, let's go back and then let's hop forward. Let's try this. Okay, and then QUERYSEQUENCE 1. Oh, okay, it's glitched because I did everything out of sync before. All right, there we go. It was a problem on there. For once, it was a problem on their end and not my end. I don't want to set up. So now we're going to check the balance of the shopkeeper. So once we have that transaction, we're back in base terminal here, which for some reason doesn't have the Libra thing, but let's try this. So we're going to do query. We're going to check the account sequence. This is typed like I'm a texting team. From the hero, which is number 1, to our account, and if it's true, and this will spell a bunch of technical deep jargon, or not, hold on. QUERYTXN underscore ACCSEQ, right? 1, 0, true. Alright, do I have to do that back and forward thing again? Okay. Oh, I have to type the whole thing out. Libra. So I actually have to type this part. Query TXN, the Texan, but no, it's more of the text account sequence. 1, 0, true. Or what do you want to? Ah. Okay, so I guess we weren't supposed to type that. We were just supposed to read all of this like we're crazy. So let's see. Now we got Now that here is paid you, we can make sure that's a query balance. Check the shopkeeper's balance, so that's us, so we had to enter the 0. So we accidentally had a correct result. So we could query the balance of anyone as long as we know their account address, since the data is available on the blockchain. It's different and counterintuitive to someone who only uses traditional banks. No balance is a secret. It's all on the blockchain, except everything's centralized and Facebook sells all your data. So that's all that. So this is interesting. When a query has a transaction, it is shown an actual micro Libra. A micro Libra. It's like a Satoshi, but even more annoying. It's like microdosing. I hate it. Which is defined as 1/bleh of a whole Libra. The smallest amount of unit for this currency is called a pip. So it's nice to know that pip is annoying. Python pip and Libra pip are both goddamn annoying. That's good to know. That's all we learned. The smallest thing is a pip. After we check our balance, it's called a pip. It's just like Python pip. I hate it. So we're almost done at the end here. So now we're going to connect to the testnet ourselves. Let's see. Walk you through. Okay. Practice run here. So we're going to practice going through actually doing this. This is something we do in our sleep. So as I've showed you before many times, if you've never known how to do this, right? You get to the terminal. You could use the Windows subsystem to launch a Linux subsystem such as Ubuntu, which I have, as well as Kali, which those are both that I have. On Linux, you can do CRT or just click through and find the terminal icon and double-click and it opens. And you can also do the same thing on Mac, because Mac is essentially using a weird-ass thing that's built on top of Unix, or a weird-ass mutant version of Unix. So the first thing we're going to do is use git clone. And now on some older operating systems, right? On older operating systems, sometimes you might not have the git function, so you might actually have to use your ATP or your Pacman or something and actually install git itself. If you just install like the newest version of operating system, like newest version of Ubuntu or Debian or something like that, 9 times out of 10 it already has the git command and git system installed. This has a quick history lesson. Git was developed, if I remember correctly, by Linus, the famous person who developed Linux, to essentially make revisioning and packet and manage code repository software management just way easier to use. You can push code, you can pull code, you can clone it, modify it, things like that. Hence GitHub and GitLab. Basically, Linus, the inventor of Linux, is a giant Git. Let's try this in here. So we clone that into this. And now wherever we cloned it to, whatever subsystem, we're going to go into that directory. So cd. So let's say I was already in documents and I git cloned it, that address. Now the Libra git would be in documents. So normally I would have to cd in documents first and then do this. But wherever you saved it to in terminal, you're now going to type in whatever before that git. So if it's called Libra, the folder itself is called Libra. And if you want to double check, you can also open your folder system and go in there that way. So now we should be in there. And actually, if this is an emulation of a terminal, now I want to see if I can use the list command or ls and see everything that's in here. And it didn't think that far, so that doesn't work. But what we will do is we will do the checkout system, not chunk. We're not going to chunk. That's a chunky boy. No, we're going to do the checkout, and then we're going to do the testnet. So now we switched over to the testnet system. So once that's done, we just install the dependencies, which is in a tiny shell script. So scripts, dev, set up. Normally I would do ls to find this, but I'm just following the commands here like an idiot. Oh, wait a minute. So scripts, dev, set up, sh. And normally this would take a hell of a lot longer, as we saw in that episode, but it just did all of that, and then everything is set up with Rust and everything. I wish we started with this. What the fuck? So now what we're going to emulate doing, as we did on our episode, this is basically a repeat of our episode, is now we're going to connect to the testnet ourselves. So once we've installed that, it don't take a while. It does take a while, especially if you're live streaming at the same time, as we found out. But now that we have everything installed, we can connect to it, and that's also its own script. So we're going to Normally, I just copy paste it for time, but I'm being an asshole here and kind of stretching the episode out, so I'm just going to type in everything. So we're in the scripts folder, client folder, and then the actual shell script is start client testnet sh, and that should connect all the way, and then it's going to tell me the command stuff, and now I'm actually in there, and they're already built and everything. So we're agreed with all that. So that's how you would run in. This happens way faster than it does in real life. And we're basically done. We now know all of the Libra stuff. We know how to check accounts. So basically, we just recovered the Libra episode all over again, except a lot smoother because we didn't have to install anything. And so that was that. That was the $20 donation thing. And actually, what I'm thinking now is because it is midnight, but I do feel a little kind of peppy here. I'm going to start another one of these. I'm going to try to do another quick one if I can. And then we'll end it. If it's too much, then I'll just end it earlier. I'm not going to do the app front ends. We might do the testing smart contracts. That might be fun. So it's either going to be that or the ZK sync. Which one should we do here? Anyone in chat have any suggestions which one we should do? I'm thinking either doing the testing smart contract with Truffle or doing the introduction to ZK syncs, which is a way of like a whole syncing system with Ethereum, and smart contracts with Truffles is like the same thing. If I don't hear anything in a couple of seconds, I'm just going to pick one, and then we're going to end the episode. I'll distribute all the lemons. We'll go raid a channel on Twitch, and then I get to eat food and take a nap, so that should be fun. I'm actually going to, let's see. You know what? The truffle thing, you know, I think if we visit Crypto Zombies again, we're gonna do the app front ends with Web3.js, and we'll do the 2 truffle ones. I think that's what we'll do. So I'm gonna do ZK Sync, to see what's going on. So for all of you who don't know, by the way, this was the truffle website if we were gonna do it, which is a whole tool system for testing and deploying smart contracts. ZSync basically is a solution for the Ethereum scalability. One of the newer things out there with a super fancy website with all of these crazy backers here. It's supposed to reduce gas fees and time delay and stuff. We have some comparisons to other different things such as just default Solidity itself. By developers for developers. You know what that means? That means it's a big pain in the ass. That means it's still a big pain in the ass, but less of a pain in the ass than if you just did everything just by itself. So as it says here, recently there's been some interesting research on using zero-knowledge proofs to secure token transfers between Ethereum and sidechains. Because remember we talked about ZK Snarks? This is very similar, except this has to do with syncing, which is from Matter Labs. So it's built on the ZK rollup architecture. It's a level 2 scaling solution, which all the funds are held by smart contract on Ethereum itself, with all the computations and storage are performed off chain. So remember how we were talking about, this actually ties in really well, where they were like, to reduce gas, we just made things in arrays and views. So imagine doing that with the actual cryptocurrency. So the actual funds part, like who owns what cryptocurrency, is on the blockchain. But instead of doing costly calculations on the chain, which again would increase the gas as well as slow the chain down, all the computations itself are performed by the ZK sync off the chain. So basically it's like it does a computation, it answers back to the chain itself under the smart contract, and then it adds those funds, and that's the only thing that's written instead of doing a write for every single one of those processes. They said that this takes instant confirmations and 10-minute finality for the Ethereum, meaning you instantly get a confirmation when you do a transfer because of this process, because so much of the process is offloaded, and then up to 10 minutes, it will show up on the actual blockchain itself. And that you can do mainnet security with zero reliance on third parties, and of course, because all the computations are off the chain, it's only the transactions that are on the chain. There's a lower gas cost, and everything is just faster and more happy. So what we're apparently going to learn on this, and we're going to try to do this real quick, is set up account on ZSync, deposit the Ethereum to ZSync, make payments by transferring Ethereum between the 2 accounts, track the status of the transactions, and withdraw the the Ethereum coin to the Ethereum chain. So let's do this. 16 lessons, but this is also all terminal stuff, so we should be able to breeze through this pretty fine as my voice gets louder because the air conditioner turned off. Then we're going to end the episode, I promise. Let's see here. So as I say here, both Ethereum and Z6 speak a language called JSON RPC, which just see JSON. You've seen past episodes. JSON drives me crazy. So I just see JSON. I'll put it this way: if you have a kid and you for some reason decide to name it JSON, that's a terrible thing to do. That kid's going to be beat up every day at school and every day in college, and will just never get anywhere. No one will like your kid. So if you really want to hate your kid, name it JSON. Not Jason, JSON. So the whole thing is that, as I said, it's not human readable because JSON by itself is not readable by humans, never mind the RPC variant. So there are libraries that do all the complex stuff behind the scenes. So all you need is just some JavaScript. And apparently we're going to have to get through this because they're like, if you're not comfortable with JavaScript, considering going through a tutorial elsewhere. This should be fun. Good old NPM. So what we're going to have to do is we're going to have to initiate a Node.js. So every single one of these JSON thing has a package.json file. It's located in the root directory. We've seen them on past episodes when we've looked at the GitHub source code for all of these things. By the way, for Truffle and for Solidity, if you're on Twitch and you scroll down on our GitHub, also if you look at that master tree link I sent, we do have all of the those code for both Solidity and Truffle on there. I'm actually going to put our GitHub in the chat right now. And then as like a last minute thing, if anyone wants to do donations before we end in probably 10 to 15 minutes, I do want to remind again that we are trying to raise money even starting now until November 7th for the Children's Miracle Network Hospitals, assisting children's hospitals across the United States and Canada. And we're particularly focused on, there's 14 ones called I think they're called the Children's Select Hospitals, and they're located, sorry, I can actually look this up right now. The Children's Specialized Hospitals, there's 14 of them in New Jersey. So if you want to get specifically local, or you just want to help out children with illnesses such as the current COVID situation or their disabilities and stuff around across the United States and Canada, that's what we're raising money for. There's the link in the charity for that. So now that we've got that out of the way, let's go back to JSON. So in order to start any of this sort of JSON project, you have to initiate it. And of course, we're going to go through my favorite friend that never works properly is npm. So we're going to npm init. And the Y just says accept every single thing we're going to do. So we're going to initiate this JSON and say yes to everything, which you normally never say yes to everything. By the way, fun trick with the -y. If you're good with terminal and you want to update and upgrade everything in Linux, when you do your apt command, especially if you're in Ubuntu or Debian, if you use the -y in the command, it will also say yes to everything. So you don't have to sit there and babysit all of your updates and upgrades. It will just do that for you. So we're doing the same thing with npm. So wrote to the documents here. So the tutorial, blah, 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 the main, we have the index.js and everything. That's good. So now that we have all that in there, we're going to install the dependencies using npm. So npm. One of the things that I really hate about npm for a while is that actually I was running Manjaro in Linux and I was enjoying myself and I was being an Arch Linux happy heaven to some degree. And there's this thing, because I remember Manjaro was complaining about this and multiple Arch Linux incidences, and I think even some Debian ones were complaining about this, where npm had basically stuck in a terrible boot loop where in order to correct everything, you needed to install an older version of npm, but if you installed that older version of npm, it said you weren't up to snuff, you need the newer one, so you would reinstall the newer one, but it said you need the older one, and it just did this all day. And so a lot of operating systems had to reboot themselves. I'm pretty sure if I got a new laptop now, I'd put an Manjaro on it because they got rid of that whole system. Plus, they shit-canned a lot of Python too, even before a lot of other people shit-canned Python too. So it should be way more stable now. But that's one of the reasons why I'm bitching all the time. So now we're going to install. Actually, let's see. I want to see if we can use double A's on here. Let's try this. So ethers and it should be npm install zk sync. Just want to see if we can get away with this. Okay, so we have to actually do those commands. npm install ethers or not. What is going on? It shouldn't matter which order. Okay, so npm install zk sync. What is going on? What do you want me to type? Oh, we have to. Oh, I forgot. Yeah, npm. You can do multiple packages in one line. Here I am talking about how I'm an expert in terminal, and I forget something that stupid basic. Yep. So it goes like, Warren, it's all this stuff, but everything will be okay anyhow. Create a lock file, did both, 11 packages, and there was no vulnerabilities, which is rare among npm. So yay, success. Keep going through this. So let's talk to zsync. So this is where I think the JavaScript's going to come in. So yeah, we're in the JavaScript here, and this is where we're going to start. I might have to end this here early because I normally can do JavaScript no problem, but if this gets more in depth than what I know, then I'm just like, oh, we'll do this some other time. Zero knowledge. So ZK Snark stand for, like as we covered when we did the security cryptocurrencies last September, and it came from the dark web in October for a Halloween thing. ZK Snark stands for zero knowledge, non-integrative arguments of knowledge. As I said, it sounds gibberish to you. Just check out the first October episode of last year in 2020 of Crypto Barons. So let's see. Again, we already covered all of that, so we're going to kind of get into like the root hash, the snark, and then the data for the transactions. All right, dead serious. I can't deal with this much JavaScript now. I'm sorry, I just can't. So what I'm going to do is we're just going to go back to the start screen here. And we did at least a couple of percentage of it. We did 13% of it. So I'm actually going to call that an episode. So I'm going to go back to the face screen and end all of this. So yeah, that was all the stuff for Crypto Zombies. Wow. If I knew that the Libra section was going to be the simple, if I knew the Facebook section that I hated on the previous episodes was the most frustrating advanced thing on the planet. And by the way, right now I am going to DLive to distribute those lemons. So if you are on DLive, we're do it live. We're doing that exactly right now. So stay tuned right now. I would have done that first, and I would have done the advanced solidity. Like when they said advanced solidity, they were not kidding. That was honestly a lot right there. That took me by surprise. So we're gonna put a small amount of lemons. We're gonna put like about 50 lemons in there. We're gonna do a lot more lemons during the two things I'm gonna announce shortly. But right now we are distributing the lemons right here. So you have 30 seconds to do that. And then we're going to go raid someone on Twitch while the music plays, and that'll be the end of the episode. So while that is going on, I actually need to go back to the screen mode because I want to show you the two things that we're going to announce. First of all, thank you for watching the stream, and thank you, Binary Badger, who's trying to thank me for sending that $20, which is way more than I thought I was going to get for this sort of, especially since when we had a computer problem, we had a network problem. I was so late. I was on time. And like I literally started right at 8, and then all this crazy stuff happened. So we're on 8:30. So thank you, Binary Badger, for sticking around. Thank you for donating the $20. That means a lot to us. And like I bet you anything, we're gonna go past like $600 in like a week or two from now, and you're still gonna be like the first donation that we have there. So thank you so much for that. But I do want to tell you about some of the upcoming stuff. So we're gonna announce both of these tomorrow. And the first thing is our meetup. We're going to have a hybrid meetup. I'm actually going to post the meetup URL in chat. Our website and blog will be updated for both of these, so stay tuned for that. I've titled it Bride of Hacktoberfest because every Hacktoberfest I always do like a parody of like a horror name. We had Hacktoberfest, Hacktoberfest 2.0, and then I think we had like Revenge of Hacktoberfest, and then no Return of Hacktoberfest, the Revenge of Hacktoberfest, and now in the vein of Bride of Frankenstein, the Bride of Hacktoberfest. It's going to be this Friday, October 15th, from 5 p.m. to 8 p.m. And again, this is a hybrid meetup, so we are going to be meeting in person at Subculture at 260 Newark Avenue in Jersey City. If you take the PATH train if you're from New York, you take a PATH train to my brain just died, to Grove Street and walk 4 or 5 blocks, and there you are. And the blocks are really short. There's a lot of activity going on between all of those. And to get to the PATH train, you can go by Newark, which is a huge hub. You can take the bus to where we are. You can transfer from NJ Transit trains over to where we are. You can take the Warrior taxi. There's just so many different ways to get to us in person. And of course, we are going to be social distancing. We are going to be wearing masks when we're not eating. This is not even just, we're paying lip service to like the COVID policies. It's literally because, I'll put it this way. As you all probably know, a couple of months ago, about in August, I went to a New York venue that said they were doing all the right stuff and that they would have the right response, and they didn't. And I got COVID Delta, and everyone else did. That wasn't fun. And unlike that venue and that organization, we don't want to get our members sick. And if I will tell you this, if any of you guys get sick and we find out, we are going to let everyone know publicly that that happened, and we're going to let our venue know, and they're going to probably we're going to do some precautions because they're a really good venue, and we're going to do some precautions, and, we're not going to do the thing that the crappy venue that got me sick did. Or could got me sick, because I can't confirm that's where I got sick, but since so many people got sick that night, and then 2 days later I developed symptoms, it was around the same time. Just saying. I talked to doctors and they said that's the most likely place you got sick from it. But regardless, but we are going to be meeting in person with proper social distancing measures because we are proper adults. Yes, allegedly, allegedly. But we are also going to live stream most of this, and it's going to be really cool. And I can tell you right now that we're going to have a bunch of different things. First of all, we're going to do a vote on what IRC instance we're going to move to. We're also going to have a special sort of announcement about some of the changes in our membership. I'm still here. We're still all doing stuff. DCG 201 is not going anywhere, but we do want to do a special announcement for one of the longest member and person who has been in this group forever. We're going to make some cool announcements, which involves in that, and then we're going to get right to the point where online and in person, Zevrock is going to be talking about APIs. He developed a whole unique thing for Wikipedia called Wikipedia AIs, and he's going to be talking about about how APIs can be leveraged and hacked. And then we're going to have it's to be announced, but we are going to have a special talk that you can only get in person. It's not going to show up on the live streams. That's going to be exclusive for the people there. But don't worry, because we're going to be showing something on the live stream that is kind of related. We might not do the VR stuff. I might save that for next month, so I might have to change bits of that. And if you are physically at the meetup space, we're going to have a different pre-show that we're going to announce soon. And in person, we're going to be playing, we're going to have a movie every month in person, and this movie is going to be Johnny Mnemonic. So if you want to kind of look at what people in the 90s thought the internet was going to be, which is both way less depressing yet way more horrifying at the same time than what it actually ended up being, you can definitely come in person. API hacking, it's so hot right now, right? The files are in the computer. And we're going to have 2 online activities that people can do. One is there's going to be a CTF going on that weekend that used to be called the Hacktoberfest CTF, and now it's going to be called the Dead Face CTF. And of course, we're going to do Hacktoberfest itself, which you can do in person, online. We're going to have a quick 5 to 10 minute thing about what Hacktoberfest is, and then we're going to remain the remainder of the physical meeting and the rest of the month doing Hacktoberfest. For those of you who don't know what Hacktoberfest is, it is this awesome open source thing where you can go on GitHub, you can go on any repo, especially ones that are tagged Hacktoberfest, and we're going to redo our entire GitHubs to have all these cool programs that you can do, and whether it's doing documentation or correcting errors in the code or adding new parts, basically you do, which we're going to teach during our intro, how to do a to modify on GitHub and then do a Git pull request. And if your request is accepted, if I remember correctly, it's 5 of them. You get cool stuff. It's usually a T-shirt that has that year's logo on it and things. So it's like a cool way to do coding stuff, and you get rewards back, and you can do it in person or online. We're going to teach about it both in person and online, and that's going to be our huge activity for the rest of the month. So that's going to be our meeting. That's going to be our meeting on the 15th from 5 p.m. to 8 p.m. at Subculture, and we're going to be streaming huge parts of it online. Although there's some things where we're only going to do them in person. So if you can make it in person and you're not sick and everything, definitely recommend it. The second thing is the day afterwards. I actually put the wrong date, so it's the day afterwards on Saturday. I don't know why Sunday was listed. I think that's an error. And this is also the universal time. That's also a wrong error. This is going to happen at 8 p.m. Eastern Standard Time. We're going to be doing a very special live stream. Now, originally we were going to do this last Friday, but things in the mail got screwed up and stuff. So, despite me being a huge fan of the Metroid series, I am torturing myself like I did with Solidity and waiting a week to do this very special stream where I'm going to unbox the special edition and the amiibos of Metroid Dread because I'm also a huge gamer and I love this series, and I'm going to play through it, and it's going to be my first time reactions to everything as a longtime Metroid fan. And if you like the commentary I did during the coding stuff, you should see what it's like when I'm playing video games where I'm really active. I've been told sometimes I sound like a non-dumb version of Etika, which I've actually known and met. Fun thing, if you know anything about gaming and about Etika and his streaming before he tragically passed away, because suicide is a real thing. I actually am one of the reasons why Etika got started on live stream. That's a story for a complete other time, but let's get back to the main point. So I'm going to be streaming. I'm going to unbox the special edition and the amiibos of the Metroid Dread, and then we're going to load it through the Elgato capture card. You're going to watch me play through it. Now, just doing a video game playthrough is boring, and we're going to be doing a lot more of these video game playthroughs because the idea is that we're going to attract you in by seeing me and possibly some of our other members react for the first time at various popular video games, especially a lot of them that are coming out next year. But we're also going to teach you some things. So if you don't know anything about Metroid Dread, all you need to know, particularly for this game, is that there are these evil robots that you can see in the background, that image, called Emmys, and they're indestructible, and they're kind of like the tyrant from the Resident Evil 2 games. They just stalk you everywhere, and if they catch up to you, it's an instant kill. So they're very high priority. You can't defeat them. You have to get away from them. And, we're kind of thinking like, so there's a woman and she's just trying to do her thing. But then there's all of these like automated robots that are out stalking her. And when they find her, they screw her over. Gee, what does that sound like? So while I'm playing Metroid Dread, we're gonna have multiple special guests on, even if it's only one guest because we're still waiting details. We can't announce anything now, but when we know the people are gonna be on, we're gonna announce those. But it's gonna be people who have either had huge influences and advocacy in privacy on the internet, or people who have been directly affected by or do teaching techniques on how to avoid being stalked and doxxed by either automated bots on the internet or malicious actors. So this is going to be a very packed weekend where we're going to have our meeting both in person and online on the 15th. It's going to be so full of fun stuff. And then the next day, we're going to be doing a very focused on this charity for the Children's Hospital, streaming and reaction of Metroid Dread while people learn about the privacy and security on the internet. And then the day afterwards is Master of Unlocking, which I'm going to announce that when I announce that. Might have to delay that episode just because of scheduling, but that's the plan. It's going to be a chock full weekend. So that's the stuff I want to announce. If you're interested in the Metroid Dread thing, I'm going to post it now in chat. Stay tuned if you're on Twitch right now because we're going to raid someone else's stream. Again, I'm going to go back to Facecam here. Thank you so much for attending this. Going Twitch right now. Thank you so much for attending this episode of Crypto Barons. I was really hyped for this episode, even though I knew it was going to be torture on by design. And I just really wanted to see if I could get like $1 or $2 to charity to kick off before we have our meeting, before we have the Metroid live stream and stuff like that. So I'm just blown away that everyone was so impressed by me getting tortured that we already got $20 to start off with. And so I think we're actually on a good way eventually for getting that $600. So again, thank you so much for Binary Badger for donating the $20. Thank you for all paying attention at home and watching. Thank you for anyone who's going to follow us after this, because we didn't get any follow notifications. Well, we did for D Live, but actually we did for D Live and Twitch. Badger followed us, so thank you for doing all of that. So I'm really excited. So again, our meeting is going to be on the 15th at 5 p.m. to 8 p.m., both in person and online. Then on the 16th, we're doing our special Metroid live stream at 8 p.m. Eastern Standard Time. My other show, Master of Unlocking, provided that I don't delay it, will be on the 17th. If I do delay it, it'll be on the 24th. And the next episode of Crypto Barons will be on the 23rd at 8 p.m. Remember, we do the 2nd to 4th. My nose is runny. I need to go catch it. We do the 2nd and 4th Saturdays of every month, and for those Saturdays, so this was the first episode of the Halloween where we checked out Crypto Zombies, Ooh Spooky, and boy, did it torture me. The next episode we're going to be doing on the 24th, from starting at 8 p.m. There is a blockchain platform that purportedly is set up by a bunch of free-thinking, free-spirited, and free Libre everything hackers who are like F the man, and they made this their own cryptocurrency ecosystem and their own operating system and functions on the blockchain. But all I've been able to find is references for themselves. I can't find any independent audits or references or any really references anywhere to this platform. So it might even just be ransomware. It might be a scam. It might be legit. I don't know. So basically, we're going to look at a cryptocurrency and blockchain software platform that has a cryptocurrency attached to it. That's supposed to be like hacker Libre thinking stuff, big brain stuff. And we're going to, while doing that, I'm going to teach everyone how you can set up a VM and harden a VM to test applications that you don't know about or suspicious about, so that if they are malicious and they try to eat your system, they're trapped in a VM and you can just destroy the whole thing and not have your main computer affected. So you get to learn some really cool like tech stuff in preparation towards blockchain stuff. So that's our episode. Again, if you want to follow us, you can follow us at defcon21.org. We're going to update the website tomorrow for the special Metroid live stream, as well as details about our meeting. If you want to follow us on social media, such as DEFCON21NJ on Twitter, or DEFCON21 on Instagram, and the host.social of Mastodon, and various .onion sites and GitHub, I just posted the master link tree right there. And one last time, if you want to donate to the Children's Miracle Network hospitals that we're going to be doing until November 7th, whether we're on stream or not, here's that link for that I posted in the chat. So again, thank you all for watching me suffer as I wear the actual block on a chain for this episode of Crypto Barons. Can't wait to see you this weekend for both the in-person meeting and online stream, because it's a hybrid, as well as our special Metroid stream. And I can't wait to see you on the 24th for our next Crypto Barons episode. So again, thank you for watching. Hack the planet. Dirty Teachers represent. And remember, children need you. Don't be like Binary Badger. You see this good boy that's right underneath the last incent reward that was going to sadly end before this pops up, or maybe I'll blab long enough so that you can actually get the instant reward. If you see Binary Badger right above the instant reward that's going to end in 20 seconds, be like him. He donated $20. You don't even have to donate $20. You can donate now. I posted the link of the charity in chat. It will also be on our social media and website. And there's a QR code right here. If you're stuck on the phone, you can't type in the long URL or click on it, that's fine. Just scan this QR code, and it'll take you straight to the donation page. And every little bit counts. We need to help these kids. $600. Let's go do this. We're hackers. We can do this. That's the last incent code. That's how you can or get free cryptocurrency. Enjoy the music and say hi to on Twitch. Say hi to everyone we raid. Peace, everybody. Thank you for watching the episode, and thank you, Binary Badger, for donating. Bye. Sorry, for some reason the music wasn't playing. Here we go. We're ready now.